Good morning, ladies and gentlemen. Good morning, ladies and gentlemen. I warmly welcome you all to 14th IEEE ICOST 2020. Let's begin the formal proceedings in the name of Allah, the most beneficent, the most merciful. I would humbly request Mr. Nurul Bara to recite few verses from the Holy Quran.
Bismillahir Rahmanir Rahim. وَالشَّمْسِ وَضُحَاهَا وَالْقَمَرِ إِذَا تَلَاهَا وَالنَّهَارِ إِذَا جَلَّاهَا وَاللَّيْلِ إِذَا يَغْشَاهَا وَالسَّمَاءِ وَمَا بَنَاهَا وَالْأَرْضِ وَمَا طَحَاهَا وَنَفْسٍ وَمَا سَوَّاهَا فَأَلْهَمَهَا فُجُورَهَا وَتَقْوَاهَا قَدْ أَفْلَحَ مَنْ زَكَّاهَا وَقَدْ خَابَ مَنْ دَسَّاهَا كذبت ثمود بطغواها إذ انبعث أشقاها فقال لهم رسول الله ناقة الله وسقياها فكذبوه فعقروها فدمدم عليهم ربهم بذنبهم فسواها ولا يخاف عقباها.
तमाम हमद है उस खालिक के अज़ल के लिए, सुकूत झील को देता है जो कवल के लिए. Thank you very much, Mr. Nurubara. Ladies and gentlemen, rise for national anthem. Thank you very much, ladies and gentlemen. I'm really delighted to welcome Honorable Minister for Higher Education, Raja Yasir Humayun Sarfaraz Sahab, Chairman Punjab Higher Education Commission, Professor Dr. Fazal Ahmed Khalid is with us, Worthy Vice Chancellor UET, Professor Dr. Sayyid Mansoor Sarwar Sahab, and Director Al-khwarizmi Institute of Computer Science, Dr. Waqar Mahmood Sahab, all the dignitaries and the distinguished guests. Thank you very much for being with us. Ladies and gentlemen, ICOST is a flagship event of Al-khwarizmi Institute of Computer Science, UET Lahore, that has been successfully happening at the institute since 2006. Like every other year, this year's conference is very much unique in its features, and it has gathered researchers, academics, industrial experts, public and private sector institutions from across the country and from across the globe. Ladies and gentlemen, just to present you a number, almost 176 researchers submitted their papers, and only 35 of them have qualified for the final go. As far as today's activity is concerned, after this formal ceremony, we'll have two panel sessions. One of the sessions will be having invited speaker talks, and the other session will be having paper presenters. So, ladies and gentlemen, these two sessions will be followed by a virtual and say a few words.
Bismillahirrahmanirrahim. Very Honorable the Minister of Higher Education Punjab, Raja Yasir Humayun Sarfaraz, Honorable Chairman Punjab Higher Education Commission, Dr. Fazal Khalid, Honorable Vice Chancellor, UET Lahore, Dr. Sayyid Mansoor Sarwar, invited international keynote speakers from USA, Italy, Netherlands, Germany, and China, faculty members, researchers, students, and participants. Assalamu alaikum and very good morning. It gives me great pleasure and it is my honor to welcome you all to ICOST 2020, organized virtually this year by Al-khwarizmi Institute of Computer Science, UET Lahore. The institute is known for its applied research and development activities in the area of information and communication technology in collaboration with local industries and international research and academic organizations. The institute is playing a key role in taking country forward towards knowledge-based economy and competitive industrialization. It provides the country with trained resources through a state-of-the-art training and certification program. Over the years, it has established more than 25 research and training labs in various areas of ICT, including artificial intelligence, cloud computing, IoT, and other technologies of fourth industrial revolution. KICS has received recognition as the top IT research institute in Pakistan by the study conducted by Islamic Development Bank and Higher Education Commission. It has been organizing this annual conference for the last 13 years. It is the 14th conference this year in this series. This year, we have received increased number of international submissions, showing increased confidence of international research community on the conference. The international submissions came from USA, from Europe, Italy, and Bulgaria, from Asia Pacific, China, South Korea, Indonesia, and Philippines, from Middle East, Saudi Arabia, and Lebanon, from Africa, Nigeria, and South Africa, and from South Asia, Bangladesh, and India. The conference received 176 submissions, and the technical committee comprising of international experts selected 35 highest quality papers for publication, which is less than 20% of the submitted lot, making it a very highly selective conference. Open source movement has picked up great momentum recently. We use one form of open source or the other in devices that we use in our daily lives. 90% of all software developers today use some kind of open source technology in their code. This conference has been acting as an intellectual interchange among researchers, scientists, engineers, and experts involved in open source development. It is providing a perfect platform for researchers and practitioners to embrace AI and allied technologies of the fourth industrial revolution by developing understanding of its true potential for productivity enhancement in all sectors of economy. This year, COVID-19 was selected as a special topic of research for the ICT community to bring forward innovations and it would help in prevention and mitigation of this disease. The event is organized virtually, including the technical session, invited talks, and panel discussion. The exposition is also arranged in a 3D live virtual mode. KICS research labs and 16 other industries are showcasing their products and projects. The virtual exposition also has an option of chatting live with the exhibitors. To conclude, I would say Pakistan is facing large number of challenges, including lower human development index, education index, and ICT use index. On the other hand, it has a very large young population. If the young population is provided with appropriate education and training, they can turn around the country future. The open source platform and the various technologies presented today and tomorrow during the event by KICS UET provide opportunities to exactly serve this purpose. We appreciate our collaborators, especially Punjab Higher Education Commission and Federal HEC, exhibitors, and IEEE volunteers. Without their support, we would not have been able to meet this objective. I would like to thank the technical committee headed by Dr. Ghalib, the program committee headed by Dr. Amir, the virtual exhibition team headed by Rehan Tariq, the administrative group headed by Akil Babar, coordination group headed by Kashif Bashir, and volunteers who worked tirelessly over the past few months to make this event a great success. Special thanks to volunteer Mr. Hamza, IEEE volunteer, for helping out with the arrangements for the virtual event. I hope you find International Conference on Operational Systems and Technologies 2020 a rewarding experience. Thank you.
Thank you very much, Dr. Waqar Mahmood. Ladies and gentlemen, this was Director KICS, Dr. Waqar Mahmood, presenting a brief of what is going to happen in 14th IEEE ICOST 2020. Just to present you what was happened in ICOST 2019, we have compiled a short video. So let me present you that video, ladies and gentlemen.
Conduct research and development activities in the areas of information and communication technology, and collaborate with local industries and international research and economic organizations. Punjab is going to be here, and Mr. Farmer, we have members from the industry, international industry, and speakers from various parts of the world, and acceptance day
of take rate, which is around 10% or so.
This is a fantastic meeting. I attended the opening ceremony, and it's very exciting to see so many faculty members and students at this international conference.
So very unforgettable and very good experience. I think it also is my first time to participate. We have a different speakers very rich because we because we
लॉजिस्टिक से टॉप स्केड्यूल की तो आई डोंट नेचुरली ऐसा हुआ है या क्या हुआ नो बट जस्ट रिपोर्टेड पूरी चीज पूरी स्टोरी बनी
I think it's very good for the students because it gives them the perspective of the not only inside the country but also around the world. I would like to congratulate Dr. Vaka organizing team for such an excellent work.
Ladies and gentlemen, I hope you enjoyed a few glimpses from the past. Now, I would humbly request Worthy Vice Chancellor UET, Professor Dr. Syed Mansoor Sarwar, to say a few words.
Dear participants of ICOST 2020, this is Syed Mansoor Sarwar. I am Vice Chancellor of the University of Engineering and Technology, Lahore. ICOST has been a torchbearer for the past several years in various engineering disciplines, specifically for the computer science community. It is gratifying to note that the agenda of this conference covers a wide range of topics related to recent advances in the field of open source software systems and technologies, software applications, databases, networks, information security, open source software and innovation, embedded computing, cloud computing, virtualization, artificial intelligence for knowledge discovery, automation, AI, applications for COVID-19 detection, diagnosis, treatment, prevention, evolution, control, and prediction, etc. ICOST 2020 is a great opportunity for professionals, private and public sector organizations, researchers, and students to discuss the needs of future applications and current challenges in adopting and developing open source solutions. AI technologies are considered the most demanding technologies of the current century. According to the trade market trends, countries like China, Germany, and the USA have released strategies to promote the use and development of AI. Industrialized countries and their governments are pushing their knowledge economy frameworks with investment in science and technology and are playing a critical role in their strategies. There is dire need for Pakistan to keep the due focus on the development and use of AI technologies since they have the potential to boost our economy in several areas and enhance our exports to several $billion per year. In recent times, several initiatives have been launched at the national level to take advantage of the current wave of AI. I feel truly honored and proud to share that UET Lahore has won funding under all these centers after a healthy competition amongst other universities across the country. Our 4 state-of-the-art R&D labs under each of these centers are flourishing under the dynamic faculty of the UET and contributing to the socio-economic benefits to the nation. Therefore, a platform is needed for researchers, engineers, academics, as well as industrial professionals from all over the world to present their research results and development activities in the latest computing technologies. In this regard, I thank the ICOST 2020 organizing team for providing opportunities to the delegates to exchange their research findings and ideas with others. I would suggest that the participants further strengthen the collaborative research and development relationships. At the end, I wish the best to the organizers and participants of ICOST 2020.
Thank you very much, Worthy Vice Chancellor. Ladies and gentlemen, this was Professor Dr. Syed Mansoor Sahib with his welcoming remarks. Now, quickly moving forward, we have Chairman Punjab Higher Education Commission, Professor Dr. Fazal Ahmed Khalid, who has got extensive experience of research and academia, who is Sitara Imtiaz bearer. I would humbly request Professor Dr. Fazal Ahmed Khalid to say a few words.
Thank you very much, Rehan. And let me first of all congratulate the University of Engineering and Technology and Al-khwarizmi Institute of Computer Science for organizing this ICOST 2020. And I'm sure that this will provide a big platform for all the researchers and technologists and engineers and scientists to contribute at this platform, which is now a recognized platform at international level, because this is a continuation of the series of conferences that were held in the previous years. And this time it is going to be conducted online. And let me congratulate the organizers, Dr. Waqar Mahmood and his team, for making all the arrangements and inviting the speakers to come to this platform and contribute in best possible manner for the advancement of science, engineering, and technology. Ladies and gentlemen, this conference is very critical from the perspective of IT and the software technologies, which have become very important and critical in the modern times. And in the last few months, in Pakistan and world over, we have witnessed that education technology has played a very important role in continuation of our activities, whether it is in academics or in industry or any organization, work from home. The new normal has become very important, and this would not have been possible without the advancement in the field of computer science, engineering, and the disruptive technologies from artificial intelligence to data science to machine learning and 3D printing and many other softwares which have become very important and critical to provide us a platform to work and to engage and contribute in various organizations, in various activities and various programs. This conference, which is organized at UET, will not only give opportunities to the faculty working in different institutions, but also there is a participation from international forums and universities and organizations, and I'm sure that this will allow to have exchange of views and ideas to learn many new things in the field of computer science and software development. Punjab Higher Education Commission has also tried to bring in some new developments. We are developing a portal for the province to facilitate our students and faculty members in terms of admission, in terms of employment opportunities, scholarships, so all kind of academic kind of information that would be available at this portal. And this portal has various levels of engagement, from career counseling to management to various aspects of cooperation and employability and job prospects that might be available in various institutions. So the students on a click can find this information available, which unfortunately is not yet available. So technology is the way forward, and no country can make progress without focusing on science, technology, engineering, mathematics, including social sciences, liberal arts, so that we can not only provide opportunities to the scientists and to the graduates of the country, but also see that the holistic education should be available, coupled with the developments happening in the world, and that knowledge and information is shared at a platform like ICOST. And let me say that the University of Engineering and Technology has taken a lead and has established ICOST as an international platform with serious kind of review that is carried out as far as the publications are concerned, the research papers that are published and submitted to the conference with a rigorous review, and the credit goes to the organizers and the committee who has worked day and night to make this a successful event. And I wish all the best to the organizers, Dr. Waqar Mahmood, the Director KICS, and the Vice Chancellor, University of Engineering and Technology, for his patronage and support. And whatever support you need from PHEC, would be very happy to do that. And let's work together, because IT, artificial intelligence, data science, 3G, 4G, 5G is the way forward. And I think we have to see that our education technology-related activities are up to date with the modern world, and our students and our faculty members are well trained, and they are up to date with the modern technologies so that their competency, their knowledge can be transferred to the youth of this country. And thank you very much for letting me have this opportunity. And I wish all the best again to the organizer and the participants of this conference, the keynote speakers, and the body of students at the UET. Thank you so very much, and may God bless you.
Thank you very much, Professor Dr. Fazil Ahmed Khalid, for being with us. In words of Iqbal, वही जहां है तेरा जिसको तू करे पैदा ये संगो खिश्त नहीं जो तेरी निगाह में है. This year's conference is somewhat different from the past conferences, as it is going virtual, and we are using Cisco WebEx tool for this, ladies and gentlemen. How difficult it is to make it virtual, and how we are coping up with pandemic. We're really honored to have Parliamentary Secretary for Health, Dr. Nosheen Hamid, with us. So I would request Dr. Nosheen Hamid to say a few words.
Bismillahirrahmanirrahim. I'm Dr. Nosheen Hamid, the Federal Parliamentary Secretary for National Health Services, Regulation and Coordination. I would like to thank KICS UET for inviting me to the 14th International Conference on the Open Source Systems and Technologies. I think this is a great platform for the researchers, academics, and industrial experts to exchange their ideas on a wide range of topics related to open source systems and technologies, software applications, artificial intelligence, cloud computing, especially the AI applications for COVID-19 detection, diagnosis, treatment, prevention, evolution, control, and prediction, etc. All these technologies are considered to be the most demanding technologies of the current time and also of the future. In the end, I would like to wish the best of luck to the organizers and participants of ICOST 2020.
Thank you very much, Dr. Saiba, for being with us. Ladies and gentlemen, this was Dr. Nosheen Hamid, who was presenting his brief. Let's quickly move forward. The man who has always been supporting such a cause, the man who has always been there for us. I would humbly request the chief guest of today's occasion, Honorable Minister for Higher Education, His Excellency Raja Yasir Humayun Sarfaraz Sahab, to please say a few words.
Bismillah ar-Rahman ar-Rahim. I'm very pleased to know that IEEE's 14th Conference on Open Source Software Systems is being organized by Al-khwarizmi Institute at University of Engineering and Technology. I think it's very important that our students learn how to use this open source software and become part of this free software movement, because I think that is the key, especially for the third world countries, because open source software is playing a major role in the future of software growth. And the role Al-khwarizmi Institute is playing by organizing this conference is commendable. Our government is encouraging research in the field of software, and we want our students to learn new software technologies. I think it will be an excellent opportunity for students, researchers, academia to know what is happening around the world in this area. And I wish Al-khwarizmi Institute the best of luck, and I hope they keep doing the good work they're already doing. Thank you very much.
Thank you very much, Minister Sahab. So, ladies and gentlemen, this was Minister Higher Education Raja Yasir Humayun Sarfaraz Sahab speaking at the opening ceremony of 14th IEEE ICOST 2020. And this concludes the opening ceremony, ladies and gentlemen. But this is just the beginning of the 14th IEEE ICOST 2020. We have so many activities. We have 2 parallel sessions going on. We have a virtual exposition, so you can have a look at the showcase of what is happening at Al-khwarizmi Institute of Computer Science in R&D sector. Ladies and gentlemen, take good care of yourself. Thank you very much for being very patient.
नहीं मेरी ऑडियो ठीक है?
जहीर मेरी ऑडियो ठीक है? Dr. Hamza, everything okay?
Can you guys hear me?
I can hear you.
Yeah, I hope I am on the right time because I'm seeing that on the WebEx schedule, my session was at 9:30, but on my email I got it was 10:30.
So, Dr. Mazam, you are right on time. No problem.
Yeah.
We are starting, we're just going live in 2 minutes.
Okay.
Bismillah ar-Rahman ar-Rahim. Allahumma salli ala Muhammad wa ala ali Muhammad wa barik wa sallim wa salli alayhi. Assalamu alaikum and good morning. On behalf of the organizing committee, I welcome all of you to the 14th IEEE International Conference on Open Source Systems and Technologies, ICOST 2020. My name is Dr. Amir Mahmood. I am Associate Professor at KICS UET Lahore. I'm also the Head of High Performance Computing and Networking there. I will be the session chair for the first session of the invited talks. The title of this session is Cloud Computing and Deep Learning. There will be 3 talks in this session. Each speaker will have 40 to 45 minutes time for the talk. And at the end of the talk, we will take questions from the audience. Attendees who have joined us through WebEx interface can write question in the Q&A dialog box, and the moderator will then collect these questions and present to the presenter. So our first speaker is Dr. Mozam Khan, who is currently working as a software engineer at IBM Security System for the QRadar-based user behavior analytics application. Before joining a development role, Dr. Khan was involved with the Watson for cybersecurity group as a researcher for another QRadar-based application called Watson Advisor. He has also worked with the engineering team for IBM's IPS and IDS solutions such as GEX, M, and XES series. He holds a doctorate degree from Georgia Institute of Technology in Electrical and Computer Engineering. He regularly writes for securityintelligence.com on topics related to cybersecurity and data science. He's also an adjunct faculty at Kennesaw State University. Today, he will talk about applying machine learning to cybersecurity data, a case study of user behavior analysis. So without further ado, I would like to invite Dr. Mazhar Khan to present his talk. The floor is yours, Dr. Mazhar Khan.
Thanks, Dr. Amir, for the introduction. Let me first share my screen. Well, the icon to share is grayed out. Anybody knows what's going on? The share on WebEx is grayed out. It's not letting me share.
So let me check.
I think you have to pass me the rights.
Sir, I have already passed you the rights. Can you please check?
Yeah, it's still grayed out.
Kindly check now.
Yeah, it's just not letting me click. All the other buttons are enabled, but the one that says share screen or share is just disabled. It's grayed out. I thought it was because of the permission. I could send it to somebody, to Dr. Mahmood, and he can show the screen, and I can just talk. Would it work?
Hamza, can we solve this problem, or we should start sharing from our side?
Sir, I have tested the presentation mode. It's working from my side.
I also don't have a sharing rights. I can also not share. I have it's grayed out.
Okay. So it seems like
Sir, rights has been shared to you, Dr. Amir. Can check please.
Dr. Mozam, can you then can you share now? Because I can see share button is visible now.
Nope. I was about to email my presentation so that you guys can probably show it to you.
Okay, so
So just send an email to everybody on the thread. I think Hamza is on it. Could you please share it on your screen?
Sure, we can share.
Yeah, sorry about that. It's still grayed out. I don't know. We had a test session and everything worked fine before, but it doesn't seem to work right now. Yeah, thanks. Thanks for sharing. Thanks, guys. This talk is about basically detecting the user behavior um, on a network, and why we are interested in detecting a user behavior is because it identify a very important threat, which is called insider threat. Insider threat is not something new. It has existed from time immemorial, and we have seen that historically people have sold inside information to enemies to gain personal benefits. And in recent times, it has become more significant because people have started working from home, and they bring devices that are not secure. They use networks that are not secure, and they access sites that they wouldn't access if they were working from their offices. So this threat, insider threat, has become very important in recent years, and that's why we want to figure out ways to detect it reliably. Could you go to slide 1, please? Thank you. So in this talk, we are going to first see some examples of insider threat and some stats, which will explain to you how much damage they have done in recent years and how costly they are. And then we are going to see how to detect these attacks. I would call them traditional way of detection because they don't use machine learning. And we will see what are the flaws or weaknesses in those schemes. Then we will move on to machine learning techniques. More specifically, we will look into two types of algorithms, supervised and unsupervised learning algorithms. And then I will discuss a case study, which is called QRadar. QRadar is a SIEM application by IBM. I will explain in detail what SIEM is, because for any machine learning model, data is the key. And this is the platform. SIEM is the platform which provides bulk of the data, almost all of the data. We will also see what are the challenges when we gather data of that scale. And then I will explain some of the examples from the machine learning analytics that we use on QRadar SIEM to detect user behavior. Then we will not be justified if we don't discuss how to construct a pipeline, because for any machine learning model, pipeline is the key, because it connects data to the eventual results. So all the elements, all the components that go in making a machine learning algorithm work is made possible through machine learning pipeline. Let me tell you, this won't be the exact pipeline that we use in our product, because I'm not allowed to tell the proprietary information. But this is pretty much how you would go about constructing a pipeline. So it gives you a general idea. Then we will see some of the challenges that you face, and some future work that needs to be done in this area. Could you please move to the next one? Okay, so insider threat is, as the name suggests, is some threat that comes from inside your organization. It's not the outsiders who you are worried about. So those insider threats could be intentional. For example, a disgruntled employee who has been passed on for promotion, or somebody who has been fired, or somebody who is just not happy with his boss, and he's out to get you. So he will do things that will harm your organization. The other intentional threat could be motivated by financial gain. You sell some information of your company to your competitor for money. And other motivations are, you are driven by inner goods. For example, you are seeing something wrong happening inside the organization, and you want to go out and tell the world. Those kind of insider threats are whistleblowers. And another category is just you are good at things and you can do harm, and you just want to boast about it. And the unintentionals, there are categories which include targeting through social engineering. So inside, users are targeted through social engineering. For example, somebody would call you pretending to be from support and ask for your credentials. And once your credentials are gone, that malicious entity could do anything using your credentials. Other is lost credential. So you are not really careful with your credential. You post them on a sticky note as a on your computer. You select passwords that are not very strict, so that easy to be hacked. Other category is infected by malware. For example, you visit a website that puts some malware on your machine, and you are unaware that your machine has been infected, and that way you will be causing harm to your organization. Next slide, please. So in the recent years, we have seen some examples of both types of attacks. Who were intentional. In 2013, we saw that Edward Snowden, who worked for NSA, learned about the government's reconnaissance of a citizen, and he went public and became a whistleblower. Then in 2019, millions of credit cards were breached, and that the hacker actually boasted with his colleagues on Slacks and other social media. So that was the motivation for that kind of attack. In 2018, a disgruntled employee in Tesla got access to a machine and got data and sold it to third party. This year, recently, I think this was the most interesting attack. Twitter attack, where famous celebrities' accounts were hacked, and there were tweets saying that send them $1,000 and they will return it by doubling it, and Bitcoin address was provided. And that was made possible because some employees of Twitter were socially engineered, and they lost credentials to important servers. And through those servers, hackers got hold of those accounts. And similarly, Anthem compromise in 2015 was through a malware phishing attack and a target attack in 2013, in which a lot of credit cards were stolen. And that was also through stolen credentials on a third-party vendor. Next slide, please. Okay, so yeah, that's right. A study done by X-Force, which is a research organization by IBM, found out that 60% of all the attacks were conducted by insiders. And of those 60%, 45% were of malicious nature, meaning they were done intentionally, and 15% were where the users were unaware that they are the perpetrator. Next, please. So the top causes of these insider threats were negligence, like a user is not careful with where they visit malicious sites, they bring in the USBs and plug it into the devices. And the other were criminal insiders that are they are motivated by financial gains. Credential theft was another top cause, where their username and password were lost, and that's how the bad guys got hold of it. Next one, please. All of this is definitely with a lot of cost. Any organization that was impacted spent about $4 million to remediate, because there are a lot of costs involved. You lose business because your reputation is lost. Your customers don't want to, they lose trust and they don't want to do business with you. There is a lot of cost with notifying all the users that have been breached. Then there is a cost on detection and estimation, because you have to bring in outside consultant, third-party vendors who can help you detect the threat as fast as possible. So there were like 204 organizations that were impacted with this particular kind of threat. And the total number of incidents was about 3,000. And if we multiply that number with 4 million per incident, that cost about $12 billion last year. Next, please. So as we have seen that how important this threat is and how much damage it can do, so we need some ways to detect it, timely detect it. So first technique or traditional technique that is used is you define rule, and if something matches, if an event happen on your network and it matches that rule, then you fire an alert. An example would be a user attempts to log into a server and he's not authorized to use it. Or a user attempts to access a network resource after hours, or a user frequently and in short time changes his geolocation. But there is a limitation to this approach, because as you can see that none of these examples is like set in stone. A user may try to access a resource that he usually don't access, and he may have a legitimate reason, or user may be traveling for legitimate reason, and if we use the rule-based approach, you will get a lot of alerts which are false positive, and we don't want them. So this approach is very rigid. It cannot learn from a user behavior. So if a user behavior changes, it just fails. That's why we need a machine learning based approach which will learn from data, even if a user is changing his geolocation, he's traveling, especially these days. If he's allowed to work from home, he might have gone back home and working from there. So that way, his behavior is changing, or he might be attending some conferences and working from a remote location. So you need a way to learn from the user behavior and not just rely on a rigid user rule-based technique. Next slide, please. For machine learning based approaches, you basically use the data that is available to you, which is user data. Like, for example, how many website he visit, what kind of website he visit, what application does he use, what hours of the day does he work. And so you create models based on those data set, and then you learn from that. So there are two broader categories for ML techniques. One is supervised. So in supervised technique, your data is actually labeled as normal or anomalous. So you know what was the result of a particular data set. And the algorithms that fall into these categories are support vector machine, k-nearest neighbors, decision trees. And the other category is unsupervised learning, which is basically what we have, because having a label data is difficult. And this is the very exact solution problem that we are trying to solve. If we have the label data about which data set is malicious and which is not, then we wouldn't need that solution. So that's why this technique is used, and the examples of this technique are k-means, isolation forest, one class SVM. Next, please. So I will try to give you a brief overview. So in a decision tree, I made up this contrived example. So in decision tree, you make a tree from the label data, which will give you basically an idea how to make your decision. So for example, if a user logs in, and if he is coming in through VPN, you will mark it normal. And if the user is not on the VPN, you further check if this user is on ACL, access control list. And if he is, then he is a normal user. If he is not, then he is anomalous. So that's how the decision tree works. In K nearest neighbor, basically you rely on the neighbors, and K indicate what is the number of neighbors that you rely on. For example, if we consider that blue dots here are normal users, and there is a user which we want to classify, then we will see what are the closest neighbors. Since it is closer to more normal user, it will be classified as normal user. If it was closer to the abnormal user, it will be classified as abnormal. And then in support vector machine, what you do, you basically create a hyperplane which bisects your data set into two categories, anomalous and normal. And similarly, when the new data comes in, if it falls on left side of the hyperplane, it will be anomalous. If it falls on the right side, it will be normal. Next, please. Unsupervised category, as we know that there is no label data set. So we have the data, but we don't know if it is malicious or not malicious, and we basically classify or cluster them into different groups. For example, in these examples, there are 3 clusters, each representing a particular type of employee. One group is for software engineers, other is for accountants, and the third one is for sales team. And if a new data set comes in, you check if it falls in any of these clusters, or if it matches with any of these groups, then it will be normal. Otherwise, it will be considered as an anomaly, and it will be a malicious user. The examples are k-means, isolation forest, and one class SVM. I kind of generalized it because all of them work on the same principle. There is a very subtle difference on how the clusters are made and how the anomaly is detected. But the basic idea is the same. You create cluster, anything falls out of the cluster is considered anomalous. Next slide, please. Okay, so now we move to our use case, which is basically our source of data set. So I will take some time to explain SIEM, which is Security Information and Event Management System. What it is doing, it is basically looking at all these sources on your network, and the logs that are being generated from these sources. It looks into them and correlate it and creates a bigger picture and determines if an offense happens or not. So the logs that are getting generated are basically telling you about events. An event could be something like if a login happened to a machine, if a file was copied from one machine to another, or if a file was deleted. It could be a firewall log or a firewall event, which basically tells you if a connection was allowed or denied. It could be a proxy log, which will tell you something about access to a website. Or it could be any application log, which could be cloud-based or on-premise. For example, Office 365 logs or WebEx. Could you please move to the next one? This is an example of an event which will come from a proxy log. You can see that there is a bunch of information. First information is the date at the time when this event happened, the source IP, the user who was involved, and the website that was accessed, because this is a proxy log. So you have website information as well, a protocol that was used, and the browser used, as well as the destination IP and the port. So a lot of devices will be sending the same events, and the SIEM will be normalizing these properties from these logs. For example, it will extract date, IP addresses, username, URL and put it in a database. So each row in the database would represent an event. And as you can imagine that not all logs have the same data, so that database will be really sparse, meaning that some information will be missing in some rows. So this is how the data is collected, and this is how it would look into the database. This is important to understand because later on we will see how we will use the data to create our pipeline. Next slide, please. This is another pictorial representation of the same idea that I just described. You have a bunch of log sources that reside on your network. It includes all network devices, application servers, endpoints, and all of these events are sent into an event processor, which uses different techniques. It also uses rule-based, it uses anomaly-based, which is basically machine learning-based. It uses a statistical correlation, and using all of these techniques, it determines that if an offense happened or not. Next, please. So I will try to explain how all of this works with this example. We would need some interactivity. So in this example, there is a client which is trying to access a server over the network, and on the network we have a web proxy, and we have an IPS intrusion prevention system. We have firewall, and through these devices, the application requests the server, and the response comes back through these devices. Could you please hit enter? Okay, so this is the path from the client, which is a user, to the server. So he tried to access a website, and the request goes there, and hit enter, please. Hit enter again. Right, can you please hit enter? Yeah, so so when the user accesses that site, the site was infected with malware, and what happens that the malware is transferred back to the machine, and when that happens, this machine becomes part of a botnet, and later on, this client machine or a user machine will try to access the command and control system, and the request would go through all of these devices. And that request may happen sometimes in the future. So the point of explanation is that the first event when the user tried to access the website and the communication with the malware command and control system may happen over several days gap. But SIEM will look into these logs. It will see that a user had accessed web proxy, meaning that it had tried to access a website, and it has gone through IPS and firewall, and the same traffic was allowed back into the network, and it has gone through the devices. So it will relate all these events and know that now there has been an infection, and this client or this user has been acting maliciously, and there will be an offense generated. Next, please. So that was the whole idea of a SIEM. Now, let's discuss some challenges that we face when we try to use the data that is generated by SIEM to generate machine learning models. As I described earlier, that all the events are being put into one big database, and there are hundreds of columns that represent the information that has been extracted from those events. And the rows are also parsed. There are some information that might be missing. And for example, firewall logs may not have some proxy information like URL. The proxy logs may be missing some information about destination, for example. So the amount of this data that is generated is huge. Like, for example, in a typical organization, there might be 500K plus events being generated per second. And that results in terabytes of data per day. And then on top of it, there are so many different kind of devices that are included in the mix. For example, mobile devices, tablets, servers, so on and so forth. And then on a given organization, there are 100 millions of users. This is just a rough estimate that a typical organization may have 1 million plus users. So having to handle this data to create model is quite complex, and that's why we need to understand how all of it is put together in a machine learning pipeline. Please, next, please. So again, this is a very general pipeline. This is not the pipeline that is used in UVA for QRadar, but pretty much all the pipelines would have the same element. So first step is ingestion of data. The data that we talked about earlier that sits in a database is queried using SQL, PostgreSQL, or AQL, and that data is brought into a big data platform, which could be Hadoop, Spark, Cassandra, and this platform may reside on the same server in a different container or a different virtual machine, or it may be a totally different server. So you put that data into these big data platform, and from there, the main reason to bring it into that platform is the speed. You cannot go and query the data every so often. That will simply delay the whole operation, and it will not scale well. So once the data has been brought into the big data platform, you extract the features which will be used to build the model. Hit enter, please. And for building model, we will use one of the algorithms that were discussed earlier. It could be isolation forest, local light factor, one class SPM, or any other algorithm. And then the resulting model is stored in either JSON or Parquet file. Parquet file is a Spark format. And then you use that model to compare the user's data with the model that is learned. And based on this comparison, you either create a new alert or no alert. So this is how a pipeline is constructed. Next, please. There is now I will talk specifically about UVA application that is part of SIEM, and it has two main models. It is one model that is a time series model. We also call it individual model because it relies on the user himself. I will explain what it means. And then there is peer group model. These are peer group model because the model rely on other peers as well. For example, all the people in the engineering group, all the people in its sales would be all peers. Next, please. So time series, as the events happen on a time, so time series model is the best and the simplified model to solve this problem. And the idea is simple here. If things are happening on a time sequence pattern, and they have a pattern in terms, the pattern could either be amplitude in terms of amplitude or volume, or it could be a frequency of the event. A good example is to understand it through EKG signal. You can see that on the left hand side, the normal signal is pretty has a nice pattern to it, but any anomalous signal would have would not look like that one, and it is easier to detect the anomaly. So that's how you detect the anomalies in a time series. If the data is deviating from your usual patterns, either in terms of volume or in terms of frequency, then you can identify it as an anomaly. Next, please. One of the analytics that we use in UBA application to detect anomaly is called aggregated activity. There are a bunch of other, but I just want to take this one example. And the idea is simple. You create a model which creates a baseline of user activity, what he did. You can see that dark blue line is the baseline that you have learned from the data. And the line above is the actual activity. And you can see that there is a big difference in terms of volume of these two data sets. So you can see that there are a bunch of anomalies that are represented by the red dots. And you can detect it with 96% of confidence that this is an anomaly because it is deviating so much from the learned behavior. Next, please. And the other analytic that, or the class of analytic is peer group. In peer group, the idea is that you cluster users that show similar behavior. For example, a user that is accessing a particular asset, like a server or websites or tool, is combined into one group. Typically, people belonging to like same groups, for example, software engineers, access same set of resources. So it is really easy to determine what is their normal behavior. And the same principle is used here. You combine people into cluster and you call them as peer groups. And when the new data comes in, you determine which group this data falls in. If it falls into a group where which does not matches the peer group of that user, then it is termed as anomalous behavior. Next, please. There are again, as same as time series, there are a bunch of examples of this particular type of model, and one is defined peer group. In the defined peer group, the users have been marked which group they belong to, and that information is acquired from their LDAP, which is the directory access protocol that contains the user information. For example, what is their job department, which city they are located in, information like that. So you have that information and you provide it to the model. So model knows that a user belongs to these groups. And you can also create custom group. For example, you can create a group that is a combination of web developers, sales managers, and what you do, in this example, they have created a custom group, and the custom group is called custom group D. But when the new data comes in, the model puts it into a peer group of custom group B. So that's why an anomaly is detected, and that's how you determine the anomaly using peer group. Next, please. So there are certain challenges, and there are some future work that needs to be done. So first thing, as you notice, that this approach has a potential of generating a lot of false positive, and false positive in this application is not something you would want, because we saw that there are like millions of events getting generated. In security, you need resources to remediate and resolve those issues. If you have to look into all of those millions, then you're not doing your job well. So that's why we need to improve the accuracy. And since the data is not labeled, we cannot use training and testing data set to determine the accuracy that way. So we have to rely on other techniques. We were researching on that. Then there is this whole area of poisoning attack, adversarial machine learning, where the attacker is trying to poison the data set so that it can bypass the detection. This is another area that has a lot of promise, and a lot of work needs to be done in this area. Then the scaling of our system is very important, because you've seen that there is a huge amount of data getting generated, and it could be due to either platform limitation or the limitation of the algorithm itself, that it cannot scale well. So we need to look into these areas to scale our algorithm better. So next one, please. So that's all I've got for this talk, and I'm now open for questions.
Yeah, thank you very much, Dr. Khan, for your wonderful talk. I have a couple of questions from the audience. So one of the question is that how can we overcome negligence? So for example, just you mentioned that lots of hackers, they exploit negligence of users. So if you put sticky notes or something like that. So the common, yes, I mean the common mistakes made by people and admins. I mean, how can we overcome that? That's the first question.
Yeah, negligence. So you mentioned admin. So I see when we talk about negligence, I see common user, like a user who has been given a machine and he's just using it without following the policy of the organization. Meaning he just goes on to visit website that are of questionable nature, and that way he compromises his machine. He is not very careful clicking on links. For example, he clicks on phishing links. That way he can also compromise his machine. So these are the areas that I classify as negligent. And there it's very easy. I mean, not easy. I wouldn't say easy, because organizations have been trying to overcome it, and they do all kind of training, but still these things happen. I think more training and educating your end user not to do these things is the best defense against negligence, besides the tools that are in place. Because if the user is not paying attention to these policies that have been defined for their own protection, they will get the hacker will find a way to fool you. So that's how I see it, like more education to the user and creating more policies so that users cannot be negligent.
Also, can you shed some light on the social engineering aspect of the cybersecurity?
Yeah, so usually, as I highlighted some of these scenarios where social engineering can work. One example is that somebody just calls you on your phone and asks that there are some issues on your computer and we need to remote access it, and if you are not familiar enough, you might give them the credential, and that way they get in. Another example of social engineering is physical social engineering. For example, people can get into your physical space by just following you, and you, out of courtesy, may open doors for them. So this also coincides with the idea of negligence, because here they are trying to social engineering their way into your physical space, and you, as a result of negligence, because you are not following the policy that nobody without a badge should enter the premises, and you're letting them in. So I think this is a combination of social engineering as well as the negligent behavior from user that results in this kind of compromise.
Right. And the last question is about the VPN security. One of the attendees have asked that how security is breached when you have so many layers of policies like firewall, TMC, and private network. So how is it possible to still make a breach?
Yeah, so that's a very good question. I mean, these days, these are what you call traditional security measures, where you put a stack of security and you still get breached. There is this new concept of zero trust policy. You basically don't rely on these layers and layers of security. You simply isolate your application from rest and only grant access if it is really needed. It may sound very intuitive and very logical, but that's not how things are done. And that's why all of these layers of security get breached, because there is no one way of getting attack a system. As I mentioned, that if you have a tunnel, VPN tunnel, the user may have bring a USB stick and put it in their machine, and that way they will still be impacted because they didn't use, they didn't come through the VPN, or they visited a website. That website doesn't have anything to do with the VPN, because they just use their home network to reach the website, and that website was malware infected. And then the malware itself can be encrypted, and even if that malware is going through a VPN, the VPN has no way to decipher it, because it is itself hidden, is obfuscated, is encrypted. So that's the short answer is there is no one way to protect. So VPN can definitely be bypassed.
Right. Thank you, Dr. Mazum, for the wonderful talk. And I hope that this talk has inspired lots of our attendees to look more into cybersecurity in detail. So as a gesture, now we will present you a virtual shield.
Oh, great. Thanks, Dr. Ahmed. It was my honor to just present it. But the shield would definitely be something that I would appreciate. Thanks.
Okay, so our next speaker is Professor Claudio Graccio. Professor Claudio Graccio is an assistant professor of machine learning at the Department of Computer Science of the University of Pisa, Italy. His research is based on the fusion of concepts from deep learning, recurrent neural networks, and randomized neural systems. He co-authored several publications in machine learning journals and major machine learning conferences, including ICML, AAI, and IJCNN and WCCI. He is the founder and chair of IEEE CIS Task Force on Reservoir Computing. Today, he will talk about advances in deep randomized neural networks. So I would like to invite Professor Graccio to present his talk. Over to you, sir.
Hello, can you hear me?
Yes, we can hear you.
Okay, morning everybody. Thanks for inviting me. I'll try to share my screen right now. Okay. I guess you're seeing my screen right now.
Yes, we can see you.
Cool. All right, thanks a lot for the invitation, like I said, and it's my pleasure to present my advances in my research in this nice conference. Like it has been said in a nice introduction, I work in the field of machine learning and deep learning in particular, and it's some years that I'm doing some studies in the field of randomized artificial neural networks. So today I would like to give you some insights that could be hopefully insightful or inspiring for doing further advances. Okay, so my talk is called Advances in Deep Randomized Neural Networks. All right, so the outline of this talk is the following. We know we are talking now about neural networks and artificial neural networks, so machine learning, deep neural networks. And one interesting aspect is that if you are aware and you are skilled in machine learning, you know that randomization is present at several levels in neural networks algorithms. For example, training algorithms or regularization techniques, dropout, etc. Okay. So today I would like to show you why it is interesting to study instead the case of neural networks where some parts of the neural network architectures are fixed, okay, so are based on random weights instead of trained weights. So we study random weights neural networks where part of the connections between the layers in architectures are left untrained after the initialization. So the outline is the following. At the beginning, I try to explain you why this idea is interesting and why it could be useful to do this. Then I show you a few examples of randomization in the field of neural networks. And then the focus, the main focus of this talk is about randomization in the case of dynamical recurrent neural systems, what is called deep reservoir computing. And finally, I try to show you a few advances in the field of complex data structures. So how far can we push the methodology? Okay, so the talk of today, it's about methodology with some examples of applications, but mainly on methodology. All right. So the basic question is the following. Why should I care about randomization? Well, we all know that deep learning has been a lot successful in the last year, so the last 10 years at least. We observed a great impact of deep learning in real world applications. But yeah, in practice, in many tasks that involve, for example, cognition, like vision, speech processing, language processing, video processing, etc., then you can find a very good accuracy of your system, implementing the techniques and using the hardware typical of deep learning, so GPUs, TPUs, etc. The point is that there are cases in which accuracy is not the only constraint that you might have. And for example, you might have other constraints like time constraints or efficiency constraints. And this turns out to be more or less easily linked to the number of tunable parameters in your system. So there are many cases in which you don't want to pay the huge cost of using deep learning techniques, the common ones, for having, let's say, for example, a few percentage of accuracy more, but you may be more interested in, let's say, being able to deploy your system, for example, in an embedded system application. So the question is that we know, the point is that we know that deep learning is really successful. There are many techniques that can be used, like, for example, deep convolutional neural networks for some kind of applications. But the point is that do we really need all this machinery, all these complicated and complex and costly aspects all the time, where there are examples where we cannot afford to use all this, let's say, complexity? And one nice example is given by embedded applications. So in this case, for example, you want to embed some artificial intelligence algorithm on onboard edge devices. And example as, for example, in the case of fog computing, Internet of Things applications, autonomous vehicles, etc. Okay, so suppose you have like a sensor that is worn by your user of your application, for example, in autonomous vehicles. You are recording some information, like, for example, some kind of biophysical information from your person, from the human in the loop, It's what it said. But you also want to process this data using machine learning algorithms. So one thing is that if you want to do inference on device, this can be easy to achieve. You can use, for example, TensorFlow Lite. You have your model that has been trained elsewhere where you have the computational power, let's say, then you deploy it on a very small device, and that's okay. But sometimes, like for example, again, in the case of IoT applications, autonomous vehicles, etc., sometimes you need also to adapt and to personalize your services to the person, to the user that is using them. Okay, so when you want to go to personalize your system, then you're going to need training. And then you're going to need learning algorithms that can fit inside a very small, let's say, sensor data or a very small, lightweight computing device. Okay, like I said, like a sensor. All right. So there is the need to use resource-efficient learning algorithms. Cool. All right. And what we can see is that there exists a sort of complexity accuracy trade-off between the algorithms in the, let's say, machine learning picture. And we start all the time considering linear models, right? So these are at one edge of this picture, of this spectrum, where we have a very low complexity and at the same time also quite a low accuracy of the system. So here we are talking about very simple algorithms, things that we know a lot, like for example, linear regression or linear classification. And then when we put inside this, let's say, picture, also traditional machine learning models like AdaBoost or random forests or super vector machine like algorithms, then we are approximately here in this picture. So we have a far more complexity algorithm, and the accuracy is definitely higher than those of linear models. So when we introduce deep neural networks, we typically say that we are at the opposite edge of the spectrum with respect to linear models, where we can basically have as much complexity as we want, and we can reach even superhuman accuracy in many tasks, like I said, involving, for example, cognition. So when we want to put randomization in the field of deep neural networks in this picture, where we go, I say, is give or take there. So the idea is that we have algorithms that are featured by a small complexity, okay, slightly more complex than linear models, but the accuracy is slightly smaller than the one of the neural network. So the basic idea here is that we don't want to make use, for example, of backpropagation or backpropagation through time. So we want to avoid all the extra costs that come for training the majority of the connection inside the neural networks. And the cool thing is that we want to exploit the architectural biases of neural systems to achieve instead a good accuracy, even if the complexity is smaller. Okay, and when we talk about randomization in the field of artificial neural networks, where the roots are really very old in time, like for example, the first model of neural networks, the perceptron that was proposed in the 50s by Rosenblatt, actually that was a first example of randomization in the field of neural networks. So you can see the physical device on the left of this slide, the conceptual description of the system on the right, where we can see that the system had like an input layer that was called retina, that was used to project to this A1 area. And from the A1 area, the system projected the activations toward this A2 area called association area. Finally, from the association area, there were connections to the responder. Okay, the basic idea is that these connections between A1 and A2 were randomized. Okay, so the idea was to use a kind of nonlinear expansion into a representation layer, and from this representation layer in the association area A2, then use training algorithms to adapt to the classification of digits. That was the basic thing than with the perceptron, with the famous perceptron learning algorithm. Right, so we can see that at the time we didn't have actually the backpropagation algorithm, so there were no mathematical means, at least well-known mathematical means to adapt also the connections between A1 and A2. Nowadays we do have, but the idea was just to represent the input information, the initial information, into a higher dimensional feature space where the classification was supposed to be easier to be done by a simple algorithm, a simple discriminator. Okay, so all of these concept has been quite a little lost in the current developments of deep learning. And the philosophy behind all this, my view, is this one that is a citation for a quote from Raimi and Recht, who introduced this model random kitchen sinks and won the Test of Time award at NeurIP some years ago. So the basic idea is that they say that randomization is a way to solve a problem, a learning problem. Randomization is computationally cheaper than optimization, okay? And the fact is that if you have your neural network system, the more components you try to optimize, so you try to adapt tuning with learning algorithms, the more it takes, of course. And instead, an alternative, a very strong baseline that you might have is that you can generate many, many random non-linear neural representations like the one in the perceptron of the input, and you can achieve a similar performance in a shorter time. Okay, so instead of optimizing some nonlinearities inside your system, what you can do, you can generate a huge number of random nonlinearities in your system, and as they are random, they are faster to be computed. You don't need to train them, and overall, you can achieve a similar performance, but in a significantly shorter time. Okay, so giving a little bit of more mathematical context, the idea is that we can use a random expansion of our input into a high-dimensional feature space. And there, when we are bringing our initial problem into the feature space, there you can train a very simple linear model. So the complexity of the training algorithm is very small. The power of that linear model is small as well, but the point is that it is building upon the randomized feature expansion. Okay, so coming to the formula, we have our input. This input is, let's say, expanded into a high-dimensional feature space using some random parameters. And then using this function phi, we apply the nonlinearity. Finally, we have a combination, a linear combination of all of these features using these alpha I that are trained. Okay, so we apply learning only on a very simple linear algorithm. And then using this, we compute our output. Okay. So the basic idea, you use a random expansion into a high-dimensional feature space where your learning problem becomes easier to be solved by a linear system. Okay, so in a few words, the methodological power of deep learning is based on the fact that we are able to develop multiple representations, okay, through many nonlinear transformations. And in my view, the success from a methodological perspective of deep learning algorithms is related to these three aspects. One is the neural networks architectures. Two is the training algorithms and the way to optimize them. And three is the initialization schemes. Okay, there is a fourth leg, of course, which is high-performance computing accelerations, but I'm talking about methodological aspects of machine learning here. Okay, so artificial neural networks, training algorithms, and initialization schemes. What I'm talking about is try to remove from this equation the training algorithm. So see what is the power of deep artificial neural networks based on good initialization schemes. Okay, this field is now eating the machine learning community under the name of deep randomized neural networks. And if you, after this talk, if you are interested in going more in depth into these aspects, you can have a look at at a book chapter that I wrote with my colleague Sky Dapane from the University of Rome this year. So you can also find the link here on arXiv. And if you are planning to attend the IEEE conference 2021 in February, then you will also see there is a featured tutorial on deep randomized neural networks that I will give in that conference. So maybe we can also meet there. Okay, so the idea is that we have a deep neural network algorithm. We remove the aspect of training algorithms, and we find out what are the intrinsic potentialities of these kind of systems. Okay. All right. So until now, we are talking about, let's say, we were talking about traditional machine learning algorithms and standard feed-forward neural networks. So instead, from this slide on, I try to push the discussion to another level. Yeah, introducing the concept of structured data. So in many applications in our real world experience, we face with structured data. So data that are not just like static images, for example, data that contain a structure, an inherent structure in between the elements of this information, like time series is one great example that come, for example, in music processing, in the Internet of Things, in the autonomous vehicles, or for example, in the speech processing applications. But these can be pushed even further toward what we call graph processing. Okay, so in the case of time series, for example, we want our system to be able to understand our language, and that's a great thing, or classify the emotion, my level of stress, for example, when I give a talk based on some sensors on my skin, etc., etc. When we move toward graphs, we are actually taking some steps ahead. And for example, we can try to classify molecules based on the fact that some of those are toxic, some of other are not toxic, etc. So we move from classification or regression on time series, where the connection between each element is the temporal relation, okay, to the case in which we have a number of vertices and we have connections between these vertices, okay? And this is a powerful abstraction that allows us, for example, to represent molecules, like I said, or also social networks. So we can apply machine learning on the domain of molecules, for example, or also to the domain of social network analysis. Okay, so now the idea is that we want to try to classify graphs, to learn how to classify graphs. All right, when we deal with this kind of information that has an inherent relation between the objects, the individual objects in itself, then using feed-forward neural network architectures like the perceptron, okay, just to give you an idea, is not the right one, or even convolutional neural networks, of course. That is not the right choice, because they are not really able to grab the intrinsic dynamicity of the input information. Instead, what we use in practice is this concept of recurrent neural networks. Okay, so looking at the slide, we have again an input layer, and this input layer is propagated to a hidden representation layer where the neural network constructs, builds the neural representation of the original input data. And differently from the previous cases, you can see there is a loop, a feedback loop, that gives dynamics to the system. So the representation that is built in the hidden representation layer depends not only on the input that it's receiving in that particular moment, but also on the representations that the network has built in previous time steps. Okay, so in this way, you can have a fading memory of your system implicitly built in the architecture. And upon this, there is a final output layer that is called the readout layer that typically is a linear relation. Okay, so the idea is that the internal dynamics of this neural network class of architectures is able to treating arbitrarily long sequences. And when you implement this in practice, you need, at least in the very simple case, to implement this couple of equations The first equation is the dynamical equation that tells us how the internal representation HT, that we can call the state of the system because it becomes the state of a dynamical system. Okay, so the state depends on the input at the same time step t, and depends on the previous time state at the previous time step. Okay, so HT minus 1. Then, after we have the state HT, we can compute the output YT as, let's say, a combination of, as a transformation of this state HT. Okay. The interesting part is that these two transformations, the recurrent transformation, the hidden transformation, and the output transformation, those that related to the readout, okay, are parameterized by a number of parameters that are, in practice, in our abstraction, are the connections, the weights of the connections between the units, the neurons in the different layer of the architecture. Okay, so we have a input weight matrix U, a recurrent weight matrix W, and the output weight matrix B. All right. So what happens when we want to try to train these connections, these tuned parameters in our system? Okay, the same architecture that I showed you before. So in the previous slide, with the yellow input layer, the blue, input layer, yes, the blue hidden layer, and the purple readout layer, the same architecture is unfolded over time. So we have our first time step, and we produce our output. So we have the yellow information, it passes through the hidden layer, and then the output is computed, okay? Then what happens is that I have also, let's say, I add another information to the system that is the so-called loss function that computes the error that my system is performing in that specific moment. And then I have, at certain point, I have another input from my information source. So I have another time step, and I do exactly the same. So I replicate the same architecture over time. The only difference is that now the state, the representation of the time series, is now built also based on the information in the previous time step. Okay, so there is this arrow here that represents the recurrent information processing in the system. Okay, so basically I repeat the same operation again and again, and I unfold. This is the way in which it is said. We unfold the neural network architecture over time. So when I want to adapt this kind of neural network architecture, I may face a lot of problems. Like I said in the beginning of my talk, deep learning is commonly all about backpropagation of gradients in the training algorithm. So in the case of recurrent neural networks, this implies a lot of difficulties. One difficulty is that this system needs to be stable in the forward pass, but it also needs to be stable in the backward pass, because if it is not stable in the backward pass, then the gradient may explode, for example, and if it is too contractive in the backward pass, then the gradients may vanish. If the gradients vanish, for example, it means that the input at certain point has no absolute, let's say, impact on the output of my system after some time steps, and perhaps I don't want this. This could be bad. Another thing is that if these gradients instead explode, it means that, let's say, the output of my system is oversensible to the tiny little perturbation that may appear sometimes in my input time series. So, long story short, I can be able to adapt my system to a training data set, but I won't be able, I will fail for sure in generalization tasks. Okay, so recurrent neural networks are an example where doing the training can be very difficult, okay, especially online, okay? And the most important problem is that training recurrent neural networks is slow, okay? So either we accept this fact that training is slow, or we go with high-performance computing accelerators, okay? Like, for example, GPUs that allows us to train for example, long short-term memory networks or gated recurrent units networks more easily. Yeah, but this is a price that we can decide to pay or not, or we may not be able to pay this price, for example, when we want to embed the system into an edge device. Okay, like I said at the beginning of my talk. So we can try to find an alternative to this that is given, for example, by the so-called reservoir computing techniques. So here what we do is we focus on the dynamical system aspect of our hidden recurrent layer, and we study this like a discrete time, nonlinear and non-autonomous dynamical system. So we know that this blue box here is computing the state of a nonlinear dynamical system. So we have these two weight matrices, U and W, that parameterize the evolution of the orbits of this dynamical system. We choose to use randomized untrained parameters there. Okay, so in practice, we call this part of the system the reservoir. So the blue part of the system is called the reservoir because, in a sense, is not adapted. Okay, so it should provide a pool of dynamics that are all input driven. Okay, so a pool of oscillators. And on top of these random oscillators that oscillate depending on the input time series. So it's an input, it's a representation, a time series, a dynamical, let's say, representation of the input time series. On top of this, the output layer instead is very simple and is adapted. For example, using third inversion of ridge regression. Okay, so the basic idea is that we randomize the dynamical system and we only train the output function. In doing so, of course, we can have much faster and lightweight algorithms for the training part of the system. So training is restricted only to this output part. And you can have speed up in application in the orders of 100 or 1,000 times. But perhaps more importantly than that, you can scale to edge distributed learning instead of being constrained, let's say, to only your inference things in the device, in the edge device. So, but coming back to the original question, so I have this dynamical system, and these are the two, let's say, matrices where I have the parameters of my dynamical system. How can I possibly say that I do randomization there instead of optimization? Okay, so what again, long story short, what you can find is that actually what is important is the scaling of those weight matrices. So, for example, instead of tuning all the parameters inside these matrices U and W, you can just adjust, modify, tune the magnitude of the weights. So two coefficients, let's say omega and rho, in these two weight matrices. Okay, so the mathematical theory tells us that we can initialize this system randomly as long as the dynamics that we have fulfill what is called the eco-state property, that is global asymptotic Lyapunov stability condition. So we impose stability of the dynamical system and as far as the system is stable, for example, as a spectral radius that is below 1, then we know that we can use this in applications. And why it works? Because it exploits the architectural bias of recurrent neural systems. So if you initialize your recurrent neural network with small weights, so according, for example, to the eco-state property, what you find out is that your system is already able to discriminate between input time series depending on the suffix. So if your problem that if the problem that you want to solve is amenable to this kind of separation based on the suffix, like, for example, a lot of times in the Internet of Things or in autonomous vehicle applications, or human monitoring, like, for example, human trajectory estimation or something like that, then you know that you can use this kind of algorithms. All right, and the advantages, like I said, are faster learning, and that's obvious. Interestingly and intriguingly, also clean mathematical analysis, because we remove all the aspects that are related to the training algorithm, so we can study the intrinsic properties from a mathematical perspective of the system, like, for example, the architectural bias of recurrent neural networks. But also, a very cool thing is that you can implement these systems that don't require training in the internal part. You can implement those in physics. You can implement those in unconventional physics, for example, in photonics, where you can find more efficiency in the running of the system, like for example, in particular, efficiency in terms of energy. So nowadays we all want to use like GPUs, TPUs, very big systems, but they consume a lot of energy. Physical systems like photonic system in practice can be zero energy consumption. That is something much more close to what happens in our brain. In our brain, we don't consume that much energy when we process the information compared to modern GPUs. We consume far way small energy. So going to these kind of photonic implementations of neural networks can be a good way to go in this sense. Okay, and there are a lot of applications where this concept of randomization in dynamical neural networks can be used, like, for example, human activity recognition, identification of earthquakes, and of course, a lot of aspects in medical application, like estimation of clinical outcomes, identification at early stages of heart diseases. So every time that you have a time series, you can try to use this kind of algorithm, even in a randomization fashion, like I showed you in my talk. So the basic idea is that essentially you can move the training and the adaptation algorithms closer to where they are produced instead of sending to the cloud. Of course, this has also some advantages, like in terms of privacy preserving, because you don't need to transfer a lot of information over a network of systems. Okay, so you can do, for example, federation learning among all the systems deployed in the different user environments, and then you can achieve a good result. So all of these topics are matter of investigation in previous and current projects that we are doing in our Department of Computer Science at the University of Pisa. And I'd like to mention in particular this H2020 European funded project called Teaching, where we want to put, let's say, this intelligence in a human-centric way inside cyber-physical systems like autonomous vehicles or avionics. Okay, and also you can find, if you are interested, you can also find a very simple implementation of the reservoir computing algorithms and of deep reservoir computing algorithms that I'm going to introduce in a moment in TensorFlow using Keras, and you see in a very small amount of lines of codes you can have all that you need. Okay, so have a look at my GitHub if you are interested in this kind of algorithms, and I am happy to give assistance and to do projects together. Okay, the last part of the talk, and I think I'm running out of time, so I try to move faster, is related to what happens, okay, when we want to introduce depth into a recurrent neural network architecture. Okay. So we know that convolutional neural networks are featured by many convolutional layers, okay, and pooling layers. So there is a lot of layers in that kind of architecture. So the basic idea is that you want to learn representations non-linearly at progressively higher levels of abstraction. So what happens in the case of time series when you want to process a time series at different levels of abstraction? Okay, you need to, in a way, introduce this bias architecturally in your system. So this is what we did a few years ago, introducing what is called deep reservoir computing, and the model was called deep ecosystem network. In practice, it's like the system that I showed you a few slides ago for the reservoir computing. But in this case, we have the external input, that is an input time series that drives the dynamics of our first reservoir layer, our first recurrent layer. Okay, so it implements this equation. And then what we do, the state, so the representation developed in this layer becomes the input. So the exciting driving input for the second level in our architecture, okay, that implements a similar dynamical system. But now, instead of having the external input driving the dynamics of our network, now it's the state developed in the previous layer that guides that drives the trajectory of the second system, and so on and so forth. Okay, so until the last layer in the architecture. Okay, so the cool thing is that now we have a set of dynamical systems that are one nested inside the other one. Okay. After that, we can attach an output layer, the so-called readout, that is the only part that is adapted. Okay. So the basic idea is that what we hope is that inside each of these reservoir layers, we are doing temporal filtering that changes the quality of the dynamics that are developed in different layers. And then if we combine linearly all of these qualitatively different temporal representations of the input, then we can try to solve naturally problems where we have, for example, multiple timescales or multiple frequencies that needs to be taken into account. Okay, and from a mathematical perspective, another cool thing that you can do if you want to implement this in a reservoir computing perspective, you can consider all the parameters in your dynamical part of the network that are these in pink boxes, and you can try to find mathematical condition for stability. Like I said, this stability is fundamental. If you are interested in this, you can have a look at one of my recent papers in cognitive computation. All right, so the basic idea, again, is that we can achieve richer dynamics inside the hidden layers of our recurrent system, even without training of the recurrent connection. This means, for example, that you can have multiple timescales, multiple frequencies, representations inside of your system. Okay, so in practice, before this number of works in literature, it was thought that the multiple timescales and the multiple frequency were a property that were given by the backpropagation through time algorithms. And instead, in our experiments, we showed that this is not really the case. Already the architectural bias of stacking multiple recurrent layers one on top of each other leads to this kind of properties, okay, under several perspectives, like, for example, also for showing the richness of these kind of dynamics from other perspectives, like stability, like I said, but also like entropy or number of intrinsic dimensions of the system, etc. And also from a dynamical system perspective, another cool thing is that you can see that this stacking of multiple recurrent, even if untrained layers of systems, gives you dynamics closer to the so-called edge of chaos, which is a rich intrinsical region of dynamics that your neural network system can possess. Okay. Interestingly enough, also you can achieve a boost performance in applications, like, for example, here I show you results and the impact that randomization can have in achieving very good results in time series processing. Like, for example, here we have piano MIDI and muse data that are polyphonic music benchmarks. In this case, you have to forecast the piano roll configuration of a polyphonic music composition. So it's a very complicated task from the time series perspective. And you can see that deep ecosystem networks, the model that I briefly introduced, achieves higher accuracy or comparable accuracy to long short-term memory or gated recurrent units. But in the most important aspect is on the right side, the computation time is much smaller. Okay. Other examples of applications are, for example, in the medical diagnosis field. For example, we used these kind of deep neural networks to let's say classify, to estimate the or to, let's say, for medical diagnosis in the case of Parkinson's disease. And another example is given by meteorological forecasting, where these guys, Kian and others, try to forecast the solar irradiance information in different locations in California. Okay, final bit of information that I would like to convey, and I'm close to the conclusion. is that the same idea can be used to process graph data. Okay, so the basic idea is that now we have, instead of having a time series data, you can have a graph data. Okay, this graph can represent, for example, a molecule. I want a way to give this molecule, for example, an input to my deep neural network, and then the outcome of my deep neural network should be, is this molecule toxic or not? Okay, so the answer to this question. I want to, in a word, I want to classify these complicated mathematical objects that are graphs. It's much more complex than time series. So we want to use reservoir computing, and we want to because we know that deep learning for graphs, that is another interesting field of research, is featured by a lot of difficulties, like training algorithms are very, very, very slow or time demanding. Okay. So in this case, what we want to do is we want to find a faster alternative to deep learning for graphs, what we call fast and deep neural networks for graphs. Okay, very concisely, the idea of processing graph information is the following. Instead of having time step, now we have vertex. So we want to compute a representation, a neural representation, a state for every vertex in our input graph. Instead of having time relation, okay, so the previous time step in the case of time series, then we have the neighborhood relation. So in practice, the state that we compute for every vertex is a function that depends on the state that is computed for the vertices in the neighborhood of every vertex that we consider. So in practice, we extend the mathematical formalism that I introduced at the beginning of my talk in this way, where now we have a state for every vertex that is a function of the input feature that is attached to the vertex in question, plus a transformation of the states computed for the neighbors, okay, of my vertex. And this information can be parameterized, like before. So the cool thing is that I can collectively group all of these equations inside a single equation where I have my state information, my input feature matrix, and my adjacency matrix of the graph. And now I can see this is actually a recurrent equation, okay? So existence and uniqueness of solutions is not always guaranteed, but interestingly, by imposing a stability constraint to these kind of equations, we can find actually that existence and uniqueness can be actually guaranteed by focusing on the dynamical sides, okay, on the dynamical aspects of this system. So we treat this system like a reservoir, actually. We impose what I call the graph embedding stability, that is the analog of the global Lyapunov asymptotic stability of the conventional reservoirs, and we achieve in practice what is called reservoir computing for graphs. Okay, so in a recent paper that I presented in AAAI New York some months ago, we introduced a stacking of multiple reservoir for graphs layers, and besides the mathematical description and mathematical theorems, etc., the cool thing is that you can stack multiple layers of reservoirs, also for graphs, and you apply a very simple readout layer, like in the case of the perceptron, and do the classification. The classification that you can achieve is really accurate, and it's not only it is accurate, but it's really competitive with the state of the art, with very much more complicated neural networks or kernel methods for graphs. So compared to these kind of alternatives from the literature, we use something like 1,000 of the trainable parameters, and we achieve the same or even better performance. Okay, so not only it is accurate, but it's also fast. Okay, so coming to the beginning of my talk, I said that accuracy is not always the only constraint that you might have. Here you can see it's met, okay? Using randomized algorithms instead of optimization algorithms, you can achieve a good representation in your internal layers of the neural networks, and you can have both accuracy and fast training algorithms. So you can see, for example, compared to gene algorithm, that is the state of the art nowadays in classification in deep learning for graphs, we can achieve the same, more or less the same accuracy with let's say 1,000 times less training times. Okay, so there are ways that we are exploiting right now and studying right now to improve even further this this efficiency of the training algorithms, because we find out mathematically that there is some theory that tells us that actually the properties of the input graph has an influence on the number of iterations that you need until convergence of these dynamical systems. So there is a way in which we can apply, for example, pooling to the input graphs in order to reduce even further the training time that you might need in the applications. Okay, coming to the conclusion, I try to give you an overview of randomization algorithms in the design of neural networks. So starting from the original ideas in the perceptron until the very last advances in the case of graph processing. The bottom line is actually that this is a great trade-off, in my opinion, between accuracy and complexity, and allows us to exploit the intrinsic natural properties of neural networks architectures. Okay, we also can. There are also reasons that allows us to think that this kind of architecture is, or algorithms, is much closer to the way in which our real brains work. Okay, in applications, this allows fast and effective learning for structured data as well. So sequences, trees, hierarchical structures, up to the graphs that I mentioned in the last slide. Okay, so this concluded my presentation, and I thank you a lot for the invitation, for giving me the opportunity to introduce my research field in this venue. And of course, I'm happy to collaborate, of course, and to answer your question if you have any. Thanks a lot.
Thank you, Dr. Claudio, for the wonderful talk. We have a couple of questions, and I would like to ask you one by one. So the first question is that can we do some numerical weather prediction using your methodology?
Sorry, can we do kind of medical prediction related to what?
Numerical weather prediction.
Well, sorry, I didn't get the application aspect. Medical tumor prediction or something like that?
No, there are two questions. So one is that for the weather prediction. So for the weather prediction, so can we use it?
Yeah, well, actually, you can try to use this kind of system for forecasting clinical variables that you can monitor, for example, from the human. So my answer would be yes, but the point is that you need data. Okay, from my experience, grabbing data from medical applications is one of the downsides. But if you have data, other results in my group showed that actually using this kind of randomized algorithms is a great deal, because compared to alternatives, like, for example, long short-term memory, gated recurrent units, or networks, even if you have small data, you can generalize better, okay, to unseen examples. So my answer is positive, and yeah, you can download my package from my GitHub and have a look to your specific application, and perhaps let me know if it's succeeded.
Right. So another question is that can you mention that for which applications it works the best, and for which application it works for, like, it fails?
Okay, so all right, so this approach driven by the randomization algorithms, in particular when dealing with time series data, is intriguing, for example, in my view, when you are collecting data from sensorized environments, okay, or from human, okay. So, for example, in the case of sensorized environments, you have some sensors in your environment or worn by the person, by the human, and you collect this data with a certain frequency, okay. Like, for example, suppose you want to identify the position of a robot inside a hospital, because this robot needs to deliver goods or medicines or whatever. Okay, so in a few words, all the cases in which you can exploit this Markovian architectural bias that I introduced in one of the slides of the system, then fine, you can use it. Okay, so in practice, whenever you are grabbing information from sensor data, this is often the case that the mathematical ground for the reservoir computing approach works. Cases in which it doesn't work, for example, are given in the context of, in my view, given in the context of text processing. Okay, every time that the last part of your input data is more important than the first part of your input data, so every time that you can have a fading memory in your system, and based on this assumption, I mean, you can characterize your learning problem, then fine, you can use reservoir computing. Every time instead, when you don't have this fading memory property of the system that you want to model, like for example, language is not always based on this, text processing is not always based on this, because for example, the first part of a sentence can be more important than the last one, for example. So all these cases are examples where I would not go for using reservoir computing system. And actually, we find out in applications that results are not really impressive in that case. So I would go with other kind of algorithms in that case. Okay, so in a word, where you have centralized data, this is a great example of applications where you can use randomization algorithms. When you need to process like textual data or something like that, I will not go for reservoir computing.
So the last question that you can quickly answer is that relates to the first talk of the session, is that what happens if the time series data has some anomalies and your randomized neural networks can learn those anomalies, and do you reprocess it, or how do you deal with them?
So you mean semantic in the data?
Yeah.
Okay, so the semantic in the data, well, there are actually quite a number of works that try to extend this framework in the case of explicit memory system. With explicit memory, there you can try to use, let's say, semantics in the memory that is stored of your system. In the basic formulation, well, actually, this is not really the case. Okay, so the semantic should be somehow represented in the hidden layer of the system, and this could be very difficult. But if you go more like towards the neural Turing machine applications, and there are some works that exploit this concept of reservoir also there, I guess that case could be solvable.
Right. So thank you, Professor Gaccio, for the wonderful talk. We are actually running out of time, so it was really glad to have you on the session.
Thanks a lot. Thanks a lot, and have a nice day and a nice conference.
Thank you. You too.
Thanks a lot.
So as a part of appreciation, we present you a virtual shield. You can see it on your screen.
Yeah. Thanks a lot.
Okay. So as the last talk is by Dr. Abdul Wahid. He's our last speaker. Dr. Abdul Wahid is a principal member of technical staff monitoring cloud at Salesforce, United States. He has also worked at Facebook as a performance and capacity engineer. He completed his PhD from Michigan State University, United States in 1997. His research interests include performance engineering of embedded systems and servers, parallel and distributed systems, kernel and application performance, debugging and software tools. He is also a founding member of High Performance Computing and Networking Lab at KICS UET Lahore. And I have the honor of working with Dr. Abdul Wahid in the past. So today he will talk about monitoring the cloud using open source component. Sir, kindly please present your work. Sir, please unmute.
Yeah, I'm trying to unmute. But the unmute is not working.
Sir, I can hear you. We can hear you.
Can you hear? Okay, great. Because I'm still showing unmute, you can hear. Yeah, that is also but I don't know if it actually worked. Can somebody verify that that you can?
Yes, sir, we can hear you. Please go ahead.
So then I assume that you can also see my screen as well. So let's get started. So first of all, thank you for inviting me. I was taking some time off, so I accepted the invitation, and I thought that since monitoring is something that I work on a day-to-day basis, so let's examine the question of how we can use monitoring for in the cloud. And essentially, since this is an open source software conference, so let's examine the question that how can we use the open source components to build a monitoring system for cloud computing. So that's the question that I'll try to examine in this talk. So just before we get into this. For some reason, my got lost.
Sir, can you switch off your camera to save bandwidth? And now please share your slides. Sir, we cannot hear you.
The application. Sorry about that.
It would be great if you can reshare your screen, your presentation.
That's exactly what I'm trying to do. But for some reason, either I can see the screen or I can see the presentation. So let me. Right. Okay. So now if I. Are you able to see my screen now?
Not yet, sir.
For some reason, even if I try to share, it doesn't show me any windows.
Try again. I refreshed your presentation rights.
Okay.
Sir, can you email us your presentation? We can open it here. Then you can just present it.
Okay. I can. All right. I'm sending it the email. Yeah, I just sent it in the email.
Zain, can you share slides?
Sir, we haven't received any email so far. Abdul Wahid Saab, to whom you have sent the email?
So I can try sharing it again.
Sir, kindly email your slides at zains.sakif@kics.edu.me.
I sent to Shafiq and Dr. Amir. Maybe if you can make me the presenter again, I can try sharing it again.
Sir, we haven't received your email. Can you try sharing again? Sir, can you try again? Sir, we have received your slides. Kindly start, please.
Usual disclaimer. I'm just presenting this talk, which is my own views. It's not representing my employers, current or past. And also important thing of using the open source components for monitoring. And in this sense, I will maybe use a lot of examples, either commercial tools as well as open source tools. That does not really mean that I'm advocating one or the other for any particular use case. There are a lot of different factors that are at play, and each scenario has to be examined in more clarity. So be sure to understand that. So with that, let's dive right into this. So I'll start with some introduction. This is my agenda. I will talk about some background in computing in the cloud. Then we'll look into why monitoring is needed for cloud computing. And then we'll dive into some solutions that are available in public clouds, specifically for monitoring. And then we'll examine the question that what will it take if we want to use open source software components for building the same type of monitoring, and what are the requirements, what will it take to build one monitoring system. Let's get started. So I just want to give a kind of an overview of the landscape of computing, and how did we get into cloud computing. If you look at how things have been evolving, especially starting from 1990s, especially early 1990s, which is like everyone was running their application on computers. From internet, unit application has you are supposed to use internet. So this is during 2000, and then things started changing. So as we started using mobile devices, especially the smartphones, and a lot of applications that used internet as well as mobile devices. We have almost everything that you offer as a service. Even if you offer it something that can be accessed from a browser, you would also have a version of it as a mobile device, so that you could you could use it on your smartphone or a tablet, and can move around and be able to use that regardless from where you are accessing that. So with that, the number of people who are actually on the internet and using computing through these mobile devices, that actually started growing exponentially. And even though it has kind of slowed down, but still, in terms of, if you look at as a comparison to the era where people were using PCs, or personal computers for computing, compared to all these mobile devices that are using the network. The number of data to the exams, a lot of it related to what you I say track working on this. People found ways of utilizing this, even though machine learning or AI is not something new, but the amount of data that was generated, and the tools and the infrastructure that we had to use those data, that actually helped democratize the field of machine learning. So today, regardless of what type of service you offer, it's kind of an expectation that you will use it for understanding the behavior, or at least do some things that are kind of more intelligent compared to just simple programming of these devices. So this is pretty much, we are living in a time where almost everything is using or benefiting from machine learning. So for some time we have been seeing this pattern that the way computing works. So on one end, you have a lot of these devices that are connected somehow to the internet, and then there are places where you can use to run any compute jobs that require large amount of compute power. So On one hand, you had all these devices, a very large number of them. On the other side, you have these data centers, or what is essentially the back end or the cloud that offers the capabilities of computing and storage of the data, and they are all connected to these devices. So it's like two end of this compute spectrum, where these clients are typically very specific in terms of their purpose, and they can even be providing high acceleration or compute power for particular things like video or audio processing. But on the other end, we have these large data centers that hold a lot of information, a lot of storage, and provide kind of a platform to get intelligence out of those the data that are collected by those devices, and do some useful services for the users of those devices. And all these devices, they essentially access the services that live in the cloud. So if you are doing some using some of these devices for shopping online, all of this inventory and what you want to buy, and how much are the prices, and how the workflow that you will use, all of that lives as services in the cloud. And so these clouds, or the backend that we are talking about, it has its own infrastructure that has different level of hierarchy. And there are a number of deployments that are possible. In some cases, when many companies have started using these data centers as on-premises data centers, some of them continue to use that, but most of them, they have moved to public cloud. There are these large companies that offer cloud computing facilities that anybody can access and use as they need. And in some cases, there are hybrid models as well. Some companies have their on-premises data center, as well as they also leverage the public cloud-based data centers as well. So both type of models are available. So just to make sure that some of the terminology is clear when we talk about cloud computing or services in the cloud. So the basic service that cloud provides is the infrastructure. So you can easily get hardware resources, storage resources, network, and how you manage those networks. So this is kind of not the user's responsibility. Users can just bring their application, deploy on those infrastructure, and go from there. So infrastructure is the responsibility of the cloud provider. So that is the basic level of cloud computing usage, and it's called infra as a service. So the cloud provider is providing you the infrastructure as a service. And as you grow, you'll add more, or as you use it, you'll pay for it. And then a slightly higher level of using that infrastructure is that you are actually not just using the hardware resources like the compute nodes or network or storage nodes. You are actually using some services that are slightly high level. Like, for example, you need to manage your identity. If you are a company, you also need to have some kind of a VPC as well, so that you could manage some of your resources that are internal within that, and then you can expose some of the services to the end users. You want to keep some of your customers' accounts in a database, so that you could provide the specific services they need. So this is all like you are using the cloud provider as a platform provider. So these are slightly high level services from the base infrastructure that you can use. And in some cases, the end user doesn't really want to know all the details of the platform or the infrastructure. They simply want to provide some service. Like I just want to have a service that does certain thing for certain users, or for example, they can let somebody log in and provide some information and get some results back. And all I need is just have a piece of code that I have written, and I want to use it as something that will provide the service to the end user. So folks can use things like a serverless model, or also known as function as a service. It's for example, in case of AWS, it's called Lambda. And then different cloud providers, they have different names for that. So this is very close to, like where you are essentially not running anything yourself. You are actually running somebody's software, but instead of installing it on your on your desktop or laptop, you're using it from the cloud, and that's called software as a service. So these are like 3 or 4 different levels of hierarchy in which we can use the cloud. So I just wanted to mention here so that when we refer to it, it's clear. Okay, so let's now examine the question that what does it mean to monitor in the cloud? So so let's look at some of the things that are that are needed in terms of monitoring. So when we talk about monitoring, we are talking about, first of all, the different levels. For example, we may be talking about infrastructure, hardware resources that we are using as a service, or the compute or storage or network that we are using, and all of these they need to be monitored both by the service provider as well as by the user for several different reasons. Similarly, there is the second level of visibility, which is the operating system. So we can have the operating system that can provide us the resource management, and we can look at the usage, our own usage, and how our applications they are utilizing that. And then the list actually goes on. So we have several levels on top of that. You can have runtime system, you can have your own user space applications that are using the infrastructure. Cloud also has different ways of deployment, or different types of the management layers that it can provide. And if we can also have some requirements to monitor that. For example, if your application is running in Dockers containers or using Kubernetes, it has its own infrastructure to manage the applications, and there is a need to monitor that. Similarly, if you are running your jobs in public cloud, you want to also audit that. Who's running the job? What are the services that are being provided? Who is accessing those services? Who is even logging into your system? And with that comes, the security, and there are different users, especially if an organization is using public cloud. So they need to control that who can access what. So this is a whole IAM infrastructure that is available in public clouds, and that also needs to be monitored. That we want to have some way of detecting any security threats, or who's accessing and how people are accessing or using the cloud. So all of that requires a lot of a detailed monitoring infrastructure which is in place. And finally, we also need to collect some information about user level transactions. Whenever a customer is accessing a service, there may be some legal compliance requirements that we need to log some of the information that user is accessing, or what they are trying to access, or how they are trying to access the service. Think of it, for example, if a bank is online and you are doing some transactions online, and you are either withdrawing or depositing some amount in that account, there is a need to have some of that information logged somewhere, so that at some point you can go back and see what happened. And if there are all sorts of possibilities that there could be disputes, there could be bugs in the system, there could be a lot of other problems due to which you might have to go back and examine what happened. So there's, I can spend a lot of time on this, but I actually just put this list here so that I could give a high-level understanding that where the monitoring is needed and how it is needed. So I can maybe just give you a small glimpse into infrastructure OS level, and then we will move on to figure out that what are some of the common goals, that why exactly we need the monitoring. So if you look at the infrastructure level, so visibility in this case might mean that you want to look at things like your compute nodes or storage or the network. And in many cases, like if you are especially the cloud provider, You also need to know that how much power you are consuming, and if your systems are generating heat, how you are dissipating that heat. And you have to keep a closer look on all of these infrastructure level measures, and be able to monitor and respond to any kind of issues. So issues like they could be related to the operational health of the system. So if you have let's say a power outage, you want to be able to figure that out and be able to move all the services or your users to a disaster recovery type of replica of your original system, because that is the errors or faults, they are not something as as a special case. These are something that happen all the time in a real system operation, and there need to be a way to deal with those. And the cloud providers as well as the service users, both of them, they can use these this level of visibility to respond to this. And of course, their performance and security is also another level. Similarly, from operating system level, the view is slightly different. We have either the hardware resources, like you are getting a node, or you are getting like a container or a VM through which you are running your services. And operating system is obviously providing the resource management, but then somebody has to monitor those as well, that how those resources are being used, how much time the system is up, how much is the capacity that is still available in terms of the resource usage, how many IO operations are being done, because there's definitely an upper bound that is available. And if we are hitting close to that, then somebody has to make a decision to add more capacity. And also, since they are these resources, they are shared among multiple organizations, multiple applications, or multiple services. So there has to be a way to provide isolation, which is also needed from security perspective, and that needs to be monitored. And there are well-defined APIs to be able to collect that type of information. Just moving to the next slide. So there are some common goals. So instead of looking at the entire list exhaustively, I just want to look at some of the common goals that are there, and due to which observability or monitoring is needed. So as I said, if you look at it from the perspective of the provider, like for example, AWS or GCP, they are providing this type of services. So they need to monitor, because they need to know that how much of their system is available. Like if I want to access the system and get X amount of additional hardware resources, are they available, or how long it takes to make them available? There are some service level agreements that they provide that whenever I want to scale, the additional capacity will be available within certain time frames. So is that SLA being met? So all of these need to be measured, monitored, and tracked. And that's why monitoring is used at that level. Similarly, disaster recovery, maintenance, that is something that the cloud provider has to take care of. And in addition, these days, since the kind of resources that the services use, they're not just a hardware resource. Like you're not getting like a particular server from the cloud provider. You could get, but in most of the cases, it's like you are getting a VM, or you are running your job in a container, and or you have a function that you need to execute in a function as a service type of model, and that needs to be tracked. At how much resources have you reached, and more granular, it's a better return you will get out of your expenditure on the cloud. So billing is one of the requirements that the cloud providers, they will have to meet, and they use the monitoring data to provide the billing information, and where you actually spend your resources. And then from looking at the other end, which is the service owner perspective, so they also have their requirement to measure how much is the usage, and how their services are getting engagement, or how their user base is growing. So unless you have good amount of measurement. You won't get that level of insight. And on top of that, the service providers also need to make sure that their services are healthy. They are also available on their end. It's not just the infrastructure or from the provider end as well, but the service themselves, they need to be available, because the service itself might have bottlenecks due to which it might become unavailable to the end customers. So you typically don't want to have that. And also, service could also crash, and you might want to have multiple replicas of your service, so that in case of disaster, you could use those replicas. And also, the way these things work, you have to have some kind of a continuous integration and continuous deployment system in place, so that internally you are developing your service and you are releasing. And in most of the cases, that happens all the time. It's not like in old days where you have a software release every year or every 6 months or every quarter. These days, the releases happen almost all the time. So that's the one of the requirements that the cloud providers, they have to meet, and the service owners, they have to make sure that they can continue using that. And since we discussed, there's a lot of data that we generate and collect. So monitoring is the resource through which you'll collect all the user-specific data, what users are doing and how they are interacting with the service. And all of that data is used very extensively for training the machine learning model, and then using them for enriching your services. Okay, so now that we have have some idea that what monitoring is used for in cloud, so let's look at some of the available solutions in public cloud, and how those public cloud providers, they are taking care of these needs for their users, and of course also for them as well. So first of all, just like the way we use the public clouds, similar to using utilities, we use electricity or water. We have to subscribe to that service, and we depending on how much we use, we get charged based on that. The public cloud works more or less the similar way. We start by subscribing to a particular service, and then we choose from different levels or different models, like we want to use infra as a service, or platform as a service, or a function as a service, and go from there. And then we have to figure out a way to deploy and manage those services, essentially using the infrastructure, and deploy and manage our own service. And then we have to figure out a way to scale. As the users grow, we have to monitor, and then as our capacity needs increase, we have to add more capacity. And as I said, this is just like a utility model. So as we add more capacity, more usage, the cost will also grow with that. So monitoring from the provider perspective, they need to make sure that system has operational health, capacity management, and billing. So this is the part which is not visible to the customers. So as a customer, if I subscribe to AWS and GCP, all of this is hidden to me. This is all related to how the provider is managing their system, and the end result that I will see, for example, that how much capacity I have used and what is the bill that I will get. So from a service owner perspective, the things that are more interesting are the service visibility. That is, my service up, is it healthy? How is the latency that my users are seeing, and is it within the required range of the latency that we can absorb. And in many cases, I also need to, for example, audit and figure out that who's accessing the service or who's accessing the infrastructure, and is it secure? If there's intrusion or there are threats, then we need to monitor, and based on the available data, we might even have to take action as well. So in specific terms, like when we are running a service, there are lots of metrics, logs, traces, and profiles that we have to look for upkeep and performant and efficient service management. All of this data, it needs archival and have some tools that provide analytics, or if there are certain thresholds they are met, that we need to get some alerting. So all of these resources or these features, they are provided by the public cloud. So public clouds like AWS or GCP, they will have their own monitoring service that the users can interact with and get all of these features available. And in the end, there are ways to export these monitored data as well. If somebody wants to, for example, extract all the user interactions and put it somewhere else and then run some machine learning models, that's always possible. There's APIs that are available to export these data out. So as I said, AWS and GCP, they provide these services. In case of AWS, the monitoring system is known as CloudWatch. GCP has a name called Stackdriver. And minimal usage of that system in terms of metrics, logs, events that are collected as soon as you deploy a service, and you don't have to typically do anything to use the minimal available monitoring level. And if you add more features or you want to have more granular information, that's when you can add it, but then you have to pay for it extra. So so typically, we'll discuss that there are a couple of tiers that are available in terms of pricing. So this is like a repeat, so I won't spend time on this. So as I said, there are two tiers. First is in terms of pricing. First is the free tier, which is like the basic metrics and logs that are collected without any additional charge to a service user. So there are some number of metrics that will be collected at a frequency like once every 5 minutes. You can have a number of infrastructure level as well as your service level metrics that can be collected, and they provide the ways to monitor those metrics as dashboards, or you can put alerts in terms of as alarms in CloudWatch. And there's some limitation, of course, that like in case of CloudWatch, maybe like you can use maximum 5 GB of log data, and it can be retained for some time before it goes away. But then as your needs grow, then you, for example, instead of saying that, okay, my needs are not met by collecting the metrics every 5 minutes, I want to collect every second or every minute, then that can be done. But of course, it has additional cost added to that. Similarly, if you want to export some of these metrics or logs outside of CloudWatch or Stackdriver or other native monitoring system, there's additional cost for accessing the API. So everything has its own cost, and that cost will increase as we use more and more features. Okay, so I mean, if you look at this, the number of features that monitoring provides, it is pretty much inevitable. And if you look at some of the specific reasons why it is inevitable, because some of these services are native. Like for example, if you look at the cloud providers' own native infrastructure like S3 storage or serverless, you won't be able to collect all of these metrics yourself. You will need the native monitoring infrastructure for that, and that's kind of your only way of visibility into the system. So that's why it is pretty much inevitable if you are using public cloud infrastructure for deploying your services. This is typical workflow for any startup company these days. So regardless of what products or service they have, they will usually deploy it in public cloud, use native monitoring infrastructure, and use dashboards or analytics and alerts, for accessing the visibility into the service. So now let's look at some of the limitations. Like I'm trying to provide some motivation that why we should look into the open source alternatives. So there has to be some limitations due to which we have to look into this. So all this model that we just discussed in the previous slide, where we looked at cloud-based service workflow. So if you, I mean, this workflow works very well for small companies. Like you have a single service or a smaller team that is getting into cloud and using the cloud infrastructure, it works very well for them. And it is possible to, even contain the cost. And you can have your essential metrics monitored, and you can set up the alarms, and your service will work fine. But then the problem starts as the company or the service that starts growing, and the user base starts increasing, and they see more and more engagement, and the number of transactions that you are looking at that starts growing. Then the volume will increase. It will be outside of the available quota, and that's when your cost will start becoming prohibitive, and that's when we need to look into the alternative. So that leads me into the section where we discuss open source software for cloud monitoring. So this is where we want to look at what are the alternatives that are available. Okay, so that's the first slide that I have is the alternative. So we can discuss a few alternatives. So one of them is that we can use third-party commercial tools. There are lots of them. I have this few examples here. So these tools can provide some very specific services. For example, like if you want to measure the APM, like you want to do application performance management. So there are tools for that. If you want alerting for any incidents that occur in your service, there are services that are available for that. Problem with this is that as the service scale, these services either will not scale, or it will do something, one of the things which is very specific, but it will not do the other things. So we discuss a long list of things that need to be monitored. So it is possible that each one of these can fulfill one or two in the list, but not all of them. Similarly, you can also think of a way of putting together a homegrown monitoring solution. That is also possible, and depending on the size of the deployment or the kind of service that you are offering, there are lots of examples that people have done that. And unless there is there's a good reason to do that, that's not something for everyone. So it is a huge investment, and it will work only in cases where it makes sense. So then finally, let's look at the open source solution. There are a lot of these monitoring components, and I'll discuss the specific components. They are available, and they are like at least dozens of them in each of these cases, where you can find multiple solutions, and then the challenge is to integrate them. But as long as we can meet the requirements, it's possible to do. So let's briefly look at what are some of the requirements. I don't want to spend a lot of time, just touch upon some of these requirements. So some of these requirements will include things like what are the use cases. You might have different types of logs, different types of metrics, events, traces, profiles that you need to collect. Also need to support multiple cloud providers. Like you're not tied to one particular public cloud. You might your application might need to support multiple of them, or maybe all of them, depending. There are different reasons to do that, and it could be a reality that you might have to support these. You have to have different deployment models as well that you want to support. Many use cases, they support the baseline host or VM or container or serverless. So these are different types of deployment model that you have to choose. Then you have to figure out a way that how your customers are going to use the monitoring. So if somebody is deploying a service in a cloud, there has to be some things that are available without doing anything. So I call this touchless onboarding, where without any additional work, customers can get some visibility. But then on top of that, if you need something more specific, then there has to be some onboarding process that you have to put together. You also have to decide some metadata. Typically, monitoring data is two parts: the content itself, and then you have to add some metadata on top of it, so that you describe the service or where that data was generated from, and some additional identifying information with that. So moving forward, and in the end, these monitoring components, they form kind of a pipeline. So think of it that on one end, you have some collection components, then you have to provide some kind of transport mechanism, some storage mechanism, then you have indexing and search, and then you have some resources available for analyzing those data and alerting, and in the end, some API to export data out of your system. So these are typically, some components that are needed, and there are a lot of open source tools that in each one of these categories that are available. And in the end, once you even have put together all of this pipeline, you have to run it as a service. That means you have to somehow get the source code from open source, do some of your local customization, add some metrics, some visibility, so that you know that how your system is behaving. You have to have some of your own tooling so that you do your own specific things. You have to take care of CI/CD and be able to deploy it. Then you have to work with the SRE teams, or you have to have your own DevOps process so that you could respond to incidents. And in case of you have people who are interacting, which are your customers who are using logs and metrics and traces from your monitoring system. So they are your customers. You have to figure out how to interact with them if there are issues. And finally, you have to also scale your system as well. Finally, I'll just touch upon this one final part of this requirement, which is the configuration management. This is how your system is going to boot up or bootstrap in the beginning. It has to discover some of the environment, because that's where it is going to collect all of its data. And then there has to be a way of generating the configuration in a way that there's collection part of the system that can start collecting the logs and metrics. And there are multiple available choices to manage the configuration. I have given some examples here. Okay, so this is like a setup of a collection service. So I'm just showing here different parts of the service that you have to put together. So some of these require like a compute, storage, or network level of instrumentation or collecting of data, especially if you have on-premise data centers. In case of a public data center, in most of the cases, you'll have to interact with the service and how the services are being deployed, and you get your instrumentation from there. And you will eventually have to deal with the public cloud provider itself and be able to use their API to export any of their internal logs, metrics, or other type of monitoring data to your own system if you have to. But in the end, the services that we are providing, I have put together underneath this diagram, where it is showing metrics, alerts, logs, traces, profiles, APM, and essentially the AI ops and how you analyze those logs and metrics. And this is a typical pipeline that you have to put together to provide end-to-end system. Starts from collection, and you have to provide a mechanism of transport and archival. Finally, there have to be an analytic tier where users can interact through the front end, and that front end will use that analytics resources from the archived monitoring data and be able to provide value to the end users. And the reason why we have this as a pipeline is because we want to provide independent stages that interact through well-known APIs, because it gives isolation, and in case of failures, not the entire system fails. You might have parts of the system that might have partial or complete failure, but that doesn't mean that the rest of the system will stop working. And it's each of these components can have their own deployment and release mechanism and schedules as well. So this is how typically this is the open source software based ecosystem that we can use monitoring, and as in fact it can be used for other products as well, not just monitoring. Typically, what happens is you get your open source bits from an upstream Git repo, and if you have a particular release that you want to base your system on, so you get the source code from there. And then you have to have a couple of branches that you want to take. So you can have a main branch that you can use for your internal development, but initially you'll have to have some kind of development branch where you the monitoring folks can actually go to work and find all of the dependencies that are needed to build a particular open source product. If there are customization, then those customization can be kept as patches, operational tooling, config templates, and packaging specs that all need to be added onto the open source component. And once all of that is built, tested, then that dev branch is merged into the main. And that's where we typically cut a release, and there's a release branch that occurs, and we actually name that release a particular, like in this case, X1-1 that tells this is a particular build that we have. And from there, the deployment part of the automated system that takes over, it will build from that particular snapshot, test it, and then deploy it. So deployment could be multiple things. Could be like the RPM or Debian artifacts. Could be Docker images. It could be Helm charts. It could be Puppet or Terraform manifests. So there are different ways in which we can deploy, and there are different deployment mechanisms, as we discussed, that are available, and based on that, the deployment will have to take care of that. And the whole thing is that you have to look into is that all of this is typically automated CI/CD based system, but you have established kind of an ecosystem where your own local users, they can also add any features, extend the functionality of the open source software, and then be able to maintain that. And in the end, you can have all of those local patches. They can be applied back to the upstream, and then the next upstream version will have your patches as well. So that way, you don't have to maintain your local patches for a long time. And this gives you like a healthy, ecosystem where you take the source code from the open source, and then whatever changes you make, you then push them back to the upstream, and that way you don't have to maintain. And similarly, if there are other features that other users might have checked in, you can also get leverage out of that. So this is the whole, the power behind the using open source software. So now, if I want to summarize, so this is my last slide. So in summary, it is possible that we could build a monitoring system from open source component. There are lots of examples. People have done this, not like it's not been done. Only challenge is that you have to meet the requirements that we have. Identify a deployment approach, a way to onboard. We have to settle on a schema that we want to use, and then we have to operate it as a service. So once we meet these requirements, we are able to use it as a service. So this is my talk. If there are questions, I can address those.
Thank you, sir, for a wonderful talk. We have a couple of questions that we can ask. So the first question is that what kind of security application in the cloud that are available as open source?
Security so there are applications that are that can detect, for example, intrusion. For example, intrusion detection. That there are auditing applications that if somebody logs into the system, it will monitor that what are the commands that are entered. So it's not like this is not like an application. So there are the open source application. For example, I can name one. Which is OS query, for example. So it is just like whatever is happening at the OS level, you can monitor and you can query the system similar to like a language which is similar to SQL, and it can respond that what happened. But you can use it, you can configure it in a way that it can detect what has happened, or who has accessed the system, or what are the commands that somebody has run. And then you can collect those as logs, and then you can have your applications that can go through those logs, and they can identify if this is a threat and this is unusual usage, and in that case you can take action. So there are few that I remember, but there are quite a few applications that actually run in this intrusion detection area. But it's like OS query is one that comes to mind. I'm sure there are many others.
So there's one general question, that how secure cloud services are and how reliable they are.
Cloud services, yeah, this is although not related to monitoring, but in general, cloud services are actually more secure than compared to if you are running on-premise or you are running something on your own. And this is something that has a perception that has changed over time. So maybe like if somebody asked this question 10 years ago, many people will say that we don't want to use the public cloud because it is not secure. Like I mean, typically for banks or financial institutions in general, they think that their transaction, their data is very secure. They don't want to use public cloud. The reason is that when you go to public cloud, they have there are two things. One is the infrastructure level. Of course, they provide you the infrastructure for setting up the VPCs, and different users have different roles. So they have this IAM that has an entire structure that who can access what. But on the other hand, they have huge teams that whose only job is to determine the threats and then be able to respond to them. So they will have typically teams that will look for example, malwares, for example, or there are the type of programs that people could use to get into the system and be able to do damage. So they can do some of this proactive work to find out if there are threats available and then be able to provide remedies to those. And then there are also a lot of work that keeps on happening in terms of different layers at operating system or at the runtime system. For example, you are using Kubernetes, for example, or you are using a particular version of Ruby, and then there are threats that are determined. And these teams will quickly find patches that can resolve those threats and then be able to patch the system. It is not, very, I mean, it is always doable, but it's not very practical for any particular company to be able to do all of that on their own. So I would say that compared to 10 years ago, the answer to this question now is that public cloud is much more secure compared to anyone else who's running it on premise.
Sir, one last question, sir. What happens if a breach occurs or how monitoring, what are the SOPs in case of any breach? So how monitoring can help?
Yeah, so monitoring can, there are services similar to like AWS CloudWatch, where they can we can use CloudTrail or GuardDuty that can essentially audit all of the accesses to the system. So if somebody is using their own infrastructure, they can also put together something similar. And the key to capturing those incidents is that the level of details that you are capturing. So if you are doing it on your own, of course there is limitation that what you can collect or what you will collect. But if you are using any of these standard infrastructure, especially from the public cloud providers, so they will collect all of the interactions from any user. So that way, it is possible to go back and see who accessed the system at what time, or if there are customers that are accessing the system, what exactly they did, and what exactly resulted, as a consequence of that. So it is very, I mean, I wouldn't say it's simple, but it's possible to put piece together all of what happened, and then be able to analyze that how the workflow actually resulted in some kind of a security breach. And then once we can understand how something happened, it is always possible to find ways to mitigate those threats.
Sir, thank you very much for your wonderful talk. With this, sir, we will present you a virtual sheet.
Yeah, thank you. And I'm sorry for all the initial trouble with getting the slides online.
No problem, sir. So with this, in this session, we had three very informative talks by our distinguished speakers. And now we will have a lunch break here for about 40 minutes. And we will resume at 2 p.m. Pakistan Standard Time. So in the meantime, we have given a link for the exhibition. So you can go, if you see in your chat, there is a link for the exhibition. and you can visit our different stalls, virtual stalls, and see what are the products and the activities are going on in KICS and those who are presenting there. So thank you very much. With this, I conclude this session. Bismillahirrahmanirrahim. Good afternoon. Welcome to the second session of ICOST 2020. So the title of this session is Cybersecurity and COVID-19. Our first speaker of this session is Dr. Melanie Reback. Dr. Melanie Reback is the CEO, co-founder of Radically Open Security, the world's first non-profit computer security consultancy company. She's also a former assistant professor of computer science at the Free University of Amsterdam, who performed RFID security research. Dr. Melanie worked as a senior engineering manager on Zen client at Citrix, where she led their Vancouver office. She was also the head researcher in the CSIRT at ING Bank, where she spearheaded their analysis lab and ING core threat analysis and threat intelligence project. She was also called the most innovative IT leader by CIO magazine, Netherlands, in 2017, and one of the 9 most innovative women in the European Union. Her company, Radically Open Security, was named the 50th most innovative SME by Dutch Chamber of Commerce in 2016. Today, she will present her work on pen testing ChatOps. So, Dr. Melanie, you can please start.
Thank you so much. I'm just going to share my slides. Let's see. You all are able to see them, right?
Yes, we can see your slides.
Okay, excellent. So yeah, so thank you so much for inviting me. I guess this is the most efficient way ever to travel to Pakistan from Europe. Of course, I'm living in Amsterdam in the Netherlands. So thank you so much for inviting me to talk. Today, I'm going to be talking about pen testing ChatOps. The word pen testing, of course, well, hey, this is a security conference, so you all should know what that means. ChatOps, this is going to require, of course, some explanation, and I'll give you a little hint that it has something to do with chatbots. So basically, I'm sure you all are familiar with Slack, right? So, it's basically an online collaborative environment that where you have a number of different chat rooms and, split up into various topics. So I have a company that's called Radically Open Security. We are a security consultancy company. We do mostly pen testing, but we also do some incident response and trainings and, phishing attacks and things like this as services for our customers. We make use of the chat as well. We don't use Slack just because of governance issues. As they say, there is no cloud. There's only other people's computers. So instead, we use a open source, self-hosted version of Slack that's called Rocket Chat. So this right here that you're looking at is what Rocket Chat looks like. So, but it basically is more or less identical to Slack. Now, that's not unusual, but we make use of a chatbot. The chatbot that we use is called Hubot, and it is developed by GitHub, the company. So I can remember about 4 years ago, maybe 5 years ago by now, where I was actually at a conference of the DevOps Days, Amsterdam. And I had heard a presentation from GitHub, the company, and GitHub as a company is distributed globally over the internet. So, they've got some, I think they have an office in the Bay Area, but they also have staff in Europe, they have staff in, Asia, they have staff in Africa, they've got staff really all over the place. Now, what they did is they'd introduced this concept of ChatOps using this chatbot called Hubot. And what they did is they use the chat as a kind of command and control center for their DevOps. So for example, if GitHub wanted to spin up a new server, they would basically just type in Hubot, new server or something like that, and it would spin up a new server. Next they would type in, Hubot, basically you could show metrics on uptime. You were able to, basically most of the kinds of system administration commands that they were able to do, they had actually streamlined and automated to all go via their chat room. I think they were using Campfire. as their chat environment. But the point is that they actually turn their Slack-like chat room into a command line. Now, I saw this and I thought, wow, this would be amazing for penetration testing. So basically, I ran back home again and sort of asked my system administrator to really quickly, set up Rocket Chat and to set up Hubot. So this basically led us to seeing how we could actually use the chat ops workflow for a security and penetration testing company. You can see, for example, right here. So one thing that we tend to frequently do as a penetration testing company is that we build quotations. Basically, we make quotations for our customers because they come to us with pen tests. We scope it for them, and then we give them a quotation or a contract that they can sign for the work. Now you can see right here in this text, you can see it says raw spot quick scope off Melanie demo. And basically what it's doing here is we can fill in an A4's worth of XML, run this chatbot command, and then we build it. And what you can see that this build command is invoking the XML toolchain, which then builds basically on the server behind the scenes this PDF file, and then it basically spits it out. And you can see a clickable link that is going to our GitLab. And GitLab is essentially where we are storing a lot of our, basically the customer data. So for example, if we're doing things like, making pen test reports, our pen testers actually add their comments into GitLab issues. And then what happens is you can basically, as they add comments to GitLab issues, basically the chatbot can spit out these notifications that say this pen tester did this, made this comment at this timestamp. Please click here for more information. But you can see in this particular case, what's happening is it's spitting out this clickable link that is connecting to our GitLab repository. And you can even see that PDF is password protected, and it's also providing the PDF, the decryption password for that PDF. So it's really fast, it's really efficient, and yeah, this is basically the way that we have things set up. So we created a XML-based pen test reporting framework that we have completely open sourced, and it's called Pentext. So in fact, not only have we open sourced it, we've actually made it an OWASP project. So if you look for OWASP Pentext, you'll be able to find this and download it and actually be able to try running this yourselves. I actually know several other security companies that are also running our reporting and workflow framework. So basically, what you can see here is some documentation basically showing how you would need to write reports. So you can see that the basis under the scenes is XML. Most of the time we don't deal with the raw XML, but this is essentially what's happening. You can see that it is stored in, in this particular case, GitHub, just because, this is actually the public example. But when you compile this XML, it basically turns into a PDF that looks like this. So as you can see, it's, it looks like a pretty standard pen test report that most pen test companies would be using. Yeah, and then back again to this whole idea of the clickable link. Now the thing is, we've done a whole lot of optimizations on this. We've actually been also aspiring to, make this even more efficient. Not to mention to also make this whole workflow, also more secure. So one particular optimization that we've also made with this, for example, compiling quotations and also compiling PDFs, is we've actually taken this build process, and we've actually also started invoking it from our continuous integration, continuous deployment pipeline. So, and we've integrated this part of it into GitLab, because GitLab also supports CI/CD pipelines. So essentially, the way that it also works now is all one of our pen testers has to do is they just have to be able to push basically some new information to the GitLab repository. And then what happens is the CI/CD pipeline picks that up that automatically invokes a recompile of the XML, and then once again it spits out this this PDF, clickable PDF link that is password protected that anybody can look at. Now, the really great thing about this is that it has enabled a workflow that we call peek over our shoulder. Now, what this means is we've got this chat room, and Radically Open Security is a 100% online company. Of course, nowadays with COVID-19, this is not unusual because almost every company now is 100% online just because of the pandemic. But we've been doing this for 6.5 years. So we've been running a 100% online, 100% remote workflow for a very long time. Now, because we are 100% online, this means that our chat room is our office. So there is no physical office actually that people would need to go. Now, the advantage of this is that it makes it really easy to include customers in our workflow. So what we do is we invite customers to join us in the chat room. Now, the purpose of this is that once customers are in the chat room, they can actually listen to every single conversation that our penetration testers are having while we are busy breaking their stuff. There's a reason why this is called peek over our shoulder. And really, the origin story of this came from back when I was actually working in the cybercrime team at a bank, and I was dealing with pen testing companies. My experience was that the pen testing companies would kind of swoop in, and then they would just, be off in the corner doing their own thing. And when I actually wanted to know, hey, what are you doing? Like, I'd like to see what you're doing. Then they were just like, yeah, but security is hard. You wouldn't understand. At which point I'm like, okay, well, I used to be an assistant professor of computer science, specialized in computer security. Why don't you try me? And what I found was that with these pen testing companies, they operate like black boxes. And even when, I asked them, to do things to show me what they were doing, they did not turn on chat logging. They turned off bash history logging. They worked in shell. They worked in screen and forgot to turn on logging, even though I reminded them, quite a few times to do so. And the only way that I was actually able to see what they were doing was to physically stand and look over their shoulder, and of course, surprise, surprise, I saw they were using the same open source tools as everyone else, but they didn't want you to know that because they were cultivating this dependence of their customers on them because they thought that if they had this dependence, that they would get basically repeat business. I wasn't happy with this, and I also asked around, also at other companies, are you happy with this? And universally, the answer that I got was, no, we're not happy with this, lack of transparency, but what's the alternative? This was when I decided to leave the bank and to start Radically Open Security. And basically my current company, it's a social enterprise, and we optimize for transparency and openness, for knowledge transfer, and also for open source. Basically, on top of that, we've got a weird business model where we give 90% of our profits to charity. I'm actually not going to talk about that right now, but I can say we've won a whole lot of prizes for the way that we operate. But what I really want to talk about today, of course, is that openness and transparency, because, with security, as most of you watching undoubtedly know, security is a process. Security is a mindset. It's not just a set of patches that you receive in a pen test report. So really, what we're trying to do is we're trying to optimize for knowledge transfer so we can better enable the customer to be able to, do the same things next time without us. We're not worried that this is going to put us out of a job because, quite frankly, it takes at least a decade, to become a really good pen tester. And just because we're sharing some of our knowledge and sharing the openness and transparency in process, this is not, going to suddenly make us obsolete. Even if the customers learn how to do the easy things themselves, scanning or things like that. I mean, we're happy to help them do that, so they don't need us for that. And then we can basically come in for the harder things. And of course, security is hard, and real hacking, is manual work. It's not just running scanning tools. But what we found actually is that the customers really value the openness and the transparency, quite simply because, because they can actually observe our hackers at work. It's almost like receiving a free training, with every pen test that they buy. And this is actually a value for money that is actually really difficult for these closed black box pen testing companies, even the large commercial ones, to be able to compete with. What I can say is actually that this pen test, open and transparent pen testing workflow has been very, very popular. It's the reason why, Radically Open Security, as a 6.5-year-old company, we've had over 100 customers. We've grown to 40 staff members. We have Google as a customer, which of course, you don't get without having a certain level of quality. Also with Mozilla, we do work with the Mozilla Open Source Security Project, but also, Open Tech Fund. We do a lot of civil society work, but also, banks, insurance companies, governments. We just did a lot of COVID-19 contact tracing security audits. So, for example, we did the largest part of the security audit on the Corona Melder, which is the COVID-19 contact tracing app of the Netherlands. We also did work for the European Commission, basically on Protego for Poland, Immuni for Italy. We looked at Trace Together from Singapore. And also the European Commission has hired us in to do security audit work on the Google Apple exposure notification API, as well as the European EFGS, the EU interoperability interface that allows the COVID-19 contact tracing apps from different EU companies to be able to work together. This is all really high-profile work, and I think that this sort of attests to the quality, that we're able to provide, and also the popularity of this open and transparent workflow. For the European Commission, we actually set up a rocket chat that is called the EU Review Facility. And actually part of why we got this job is because the European Commission basically wanted to make sort of in a collaborative effort of looking at these COVID-19 contact tracing apps. So, basically anyone is able to log in and, basically follow, some of the work that's happening. And, all of this is really possible because of this open and transparent chat ops workflow that I'm describing right now. So, all right. So I basically mentioned that GitLab is also part of this. We've kind of like got, kind of our trilogy of software that has been making this work. So basically Rocket Chat, GitLab, and also the chatbot. So, other than that, it's actually quite simple. You can see the XML that is basically stored in the repository behind the scenes that gets basically compiled and put into that PDF file. And again, we use GitLab issues for recording our pen test comments, and also we can push things like scan input directly into the repository. So we've got other tools also that we've open sourced. A funny thing about Radically Open Security is, again, we've got a really strong commitment to open source. So if you go to both our GitHub as well as our GitLab repositories, you'll see that we have released almost all of our tools as open source. So if you like what I'm describing today, feel free to go to our repositories, download it for yourself, and try it out. You can see, for example, another example of something that we open source called the passive scanning tool, which basically correlates Shodan and Census passive scanning. But this is just one example. Basically, our entire workflow has been completely open sourced and released for free. Another thing that you can see is that we actually use this ChatOps workflow with customers in our channel to do things like gamify our customers' pen tests. So we have something that we call a red-blue pen test. So what this means is that we can take a team of software developers, sysadmins, DevOps people from a particular company. What we can do is take roughly a dozen people, and then we can divide them into two teams. So either a red team and a blue team, or a red team and a red team. Then what we can do is we can have these two teams compete against each other to hack their own stuff, each team underneath the guidance of one of our professional pen testers. As you can see, we've created a scoreboard that makes use of the chatbot. So you can see right here that you can see it says Melanie, that's me. I typed in good job blue, and you can see that the chatbot actually spits out, incremented blue 24 points, and then it prints out this this motivational image. So literally, this sort of facilitates this gamified atmosphere that enables us to be able to really, allow these software developers to step out of their role as software developer, and for a 3 to 5 day period, they can basically step into the shoes of a hacker and really learn by attacking their own code. Now, the nice thing about this is that, first of all, it really embeds the hacker mindset. And the other thing also is it makes them less defensive. Because if you come in as a third party and you say, as a pen testing company, you're doing it wrong, right? What's the reaction you're going to get from the developers? They're going to be like, no, we're not, or well, it was signed off on by management, or whatever. They'll come back defensively about this. However, if we can include them in the process and they're actually part of the team that actually did the hacking, not only are they not defensive about the fact that their own code was hacked, but they're proud of it, because they actually did it themselves. So the number one comment that we tend to get from these red-blue pen tests is, and I quote, "I will never look at code the same way again." And this is what it's all about, So really what winds up happening here is that basically for the cost of more or less a normal pen test, we can actually provide a training for roughly a dozen people. Plus, on top of that, because there's a dozen sets of eyes and a dozen brains, we can get a really, really thorough, pen test basically on this, and all of this is enabled just quite simply because of this pen testing chat ops workflow that I'm telling you about. So this is really great stuff. Another thing also that we also sometimes do with our chat ops workflow is we also do phishing tests. And this is actually really a lot of fun. What we've actually done is we have created essentially a landing page that is, it usually contains either the link that they have to click on, or sometimes there's a form that they need to fill in. And essentially, anytime somebody would fill in something into that form, basically that via an API call sends a message into our chat room that just says, the person with this, for example, basically the person just filled in this information at this timestamp. And you can actually literally see the username and password combinations that people are filling in real time. So this is actually really interesting. And the customers basically can sit there and watch in real time while their staff is getting phished. This is really awesome, obviously, for being able to transmit the hacker mindset. Same thing with also clicking on these phishing links from emails. We can also, again, make these instrumented links that then go back to that landing page, which also can send these notifications to the chat room that say this recipient just clicked on this email with this subject at this timestamp. So again, you can basically literally see as both the clicks as well as the form fills are coming in real time. And yeah, again, all of this is due to this chat ops workflow. So really cool stuff. But there's so much more actually that we can do with this. Imagine for a moment, like as a, basically as a command and control center for your pen testing operations, what you can do. I mean, you could run, for example, different kinds of scans from the chat room. For example, Nmap scans, web scanners, SQL injection tools, like SQL map, brute forcing, of passwords like Hydra. Another thing that we actually also have implemented is hash cracking. So for example, we have rainbow tables that have been implemented. So the rainbow tables basically are on our server. And what I can do is I can actually, basically via any device that's able to access our chat environment, for example, my cell phone, I can actually enter a hash and have the rainbow table basically, on the backend server. I can use that basically to get the password from that hash quickly. That's actually amazing if you think about it, because it allows you to use rainbow tables on your cell phone. Like, how cool is that? I mean, So this is all really cool stuff. You could use this also for recon, whether it's active recon or passive recon. Other things like exploitation. I already mentioned the spear phishing, but there's so many different ways that you can potentially use this stuff. You can also use this workflow for project management. So for example, for a while we were using a Kanban board, and we actually also had that tightly integrated with the chat room. So we could, for example, update the status of projects by a chat ops command. So that was kind of cool. We have this thing called raw spot charge. So for example, if there's one thing that hackers hate, it's bureaucracy and administration. And things like hour tracking, of course, is like the bane of consultants' existences. So what we do is we've got this command that is raw spot charge. And when we type this in, then the chatbot basically says, thank you, name of pen tester, for declaring, N hours. There's now N hours remaining in the pen test. You have now used up, L% of the time remaining in this pen test. And it actually shows a little progress bar showing how much of the time has actually been used in the pen test. Now, this is cool partly because it makes declaring hours really, really easy. And basically, based upon the actual chat room that this command is run in, then the chatbot knows, which project to add the hours to. But also, it's cool because it makes the billing process really open and transparent to the customers, because it's not, for customers, time is money, when you're dealing with a consultancy company. So if you can actually see the consultant declaring hours and explaining in that command exactly what those hours are being used for, the customer can actually see exactly where their money is going. And it doesn't take a whole lot of explaining to understand why this would actually be really popular for customers. Another thing also is this helps to prevent, or not to prevent, but at least to keep things like scoping errors under control. Because of course, scoping is more of an art than a science. And it's really easy to get scopes wrong. Because when you first start out scoping a penetration test, you can make an estimation of, I think the work is going to take this amount of time. But, halfway through the pen test, you stumble upon that, actually this application we're testing is way more complex than we thought. Or otherwise, it could very well be that, there's this really huge problem and this rabbit hole goes really deep and we need to actually spend a lot of time on this. Now, the really nice thing about making this process open and transparent for customers is that when we get to about halfway through the pen test, if it looks like we're going to run over scope, we can just say to the customer, dear customer, it turns out that this application is more complex than we thought. And or, we found large problems that we actually think we should spend larger amounts of time looking at. Could you help us in the second half to prioritize, which pieces of this audit work are most important to you and which pieces are least important, so we can basically cordon that off as being future work. Now, the customers love this because, of course, they understand, that we're not going to be doing a whole bunch of unpaid, work that came from scope creep or otherwise from unexpected things. And the fact that you actually give them knobs to tweak, and sort of like control over what we're spending our time on, this is the best form of expectation management. So it actually means when things go wrong with your pen test, when you're being so open and transparent, your customers see it coming from a mile away. And this means that they are not angry at you that these things happen because they're actually part of helping you solve it. And this is really, really great for customer relations. Anyway, so do keep in mind that right now I'm talking about using this for a pen testing company, but bear in mind that this ChatOps workflow is really handy also for other kinds of companies. I know some other companies who actually have seen my pen testing ChatOps talks, and they themselves have actually, started, experimenting with ChatOps in their own companies. And it's not just pen testing companies, but things like, for example, hosting providers. Same thing. They can also benefit from a more open and transparent workflow. So one of the questions I really want to pose with this talk is think about how in your organization, no matter what kind of an organization it is, you can make use of ChatOps to provide a more open, transparent, and streamlined workflow for your customers. Think about this. There's actually a lot that we can do. And also now that we're in this COVID-19 situation in which everybody is working online and remotely, it's actually more attractive than ever to investigate these kinds of workflows. Other comments that I want to make about this are things like access control. Obviously, when we start talking about basically command injection, because this is what we're talking about here, entering commands into a chat room, security starts becoming really important. Obviously, you're going to need all kinds of appropriate input sanitization, so basically filtering, because you don't want basically unfiltered user commands just to be going directly to backend shell scripts or other kinds of programs for execution. So obviously, the way in which you set this up needs to be smart. First of all, we implemented role-based access control. So you can essentially implement roles or otherwise groups in Rocket Chat, also in GitLab, and also we can make use of this with the chatbot. So first of all, we can make sure, for example, that our customers are not able to execute the commands that are intended for, say, our pen testers. So you need that form of access control. Of course, you need to pen test this stuff also quite regularly, as we also do internally. Other things that you should aim to do to try and make it this more resilient security-wise is try not to use the same chatbot in every single, in all of your chat rooms. In other words, what you can actually much better do is try and use individual chatbots because quite simply the reason why, and then put each of them into their own virtual machines. The reason why you would want to do this is because that way if somebody does manage to get some command injection on the bot and try and break out, if everything is isolated in its own virtual machine, then basically what that means is, it's really, you can't actually leverage this to be able to access other projects. So you need to also think really carefully about this. The downside of basically creating a bunch of different chatbots that are separated is it is really resource intensive. So it does mean you're going to need some pretty decent servers running for all of this, because of course it is going to have a really large memory footprint, but it's doable. I mean, it's basically just trading off some money, for the extra computational resources to get this extra security. But of course, as being a security company, we really have no choice, but to make these kinds of trade-offs, because we don't want people leveraging the raw spot to be able to try and get into different projects where they shouldn't be. Other things that are worth mentioning are things like error logs. So what we can do is we've got system administrators, of course. We're very much a DevOps company, despite the fact that we're a pen testing company. As you can imagine, I mean, this stuff is production with a capital P, because if our chat rooms and our chat op setup goes down, our entire company goes down. So, that's why, as I was mentioning before, we've really, in the last few years, made a very large DevOps refactoring for all of this. So containerization, Dockerization, putting things into individual containers, Deployment also, we're also we've been writing Ansible roles basically to be able to also, make configuration management easy. We need all of this stuff because on a sufficiently large scale, I mean, this also needs to be automated, also to prevent human error. And again, this is important security-wise. We need things to be configured correctly to also reduce the chances of this kind of setup being exploited. So, that's why, again, having adequate automation is really important. But I was anyway mentioning the error logging. The way that it is we can actually create channels, like for example, ROS error and ROS debug. And what it means is that we can actually pipe error logs into the chat room so that our system administrators can actually see the errors without needing a shell in the system. From a security point of view, this is actually great because, of course, the fewer shells we can give people, the better. So that's actually a really cool thing that we can do. We've also implemented a help menu, just because, of course, once you start getting enough commands, you need to remember what the syntax is of this, etc. And of course, you can look towards the future with things like AI chatbots. Wouldn't it be cool, if you can actually talk to them, and be able to have them do things, I mean, this is research, but of course, in the end, the sky's the limit. In the end, I mean, I think really with the pen testing chat ops, we need to understand that this is a really useful workflow. But in the end, remember, we are balancing all of this with security concerns. So what it is for us also is it's been a bit of a push and pull of sort of how many commands do we need to offer to be able to really offer the flexibility and ease of use that we would need for our workflow. But also, if there are certain things that don't need to be chat ops commands and we can actually instead take them out and put them as part of the CI/CD pipeline, that also reduces the number of things that you can exploit. So for us, it's sort of been this dance, this balancing act also of trying to make it functional enough to really be able to support our workflow so that our customers get all the stuff that they need and our pen testers get the stuff that they need. But also at the same time, we're trying to lock down as much as we can also to keep the situation as secure as possible. So this is kind of, I think, where we're at with this right now. We have won multiple awards with our company for our workflow. The Dutch Chamber of Commerce called Radically Open Security the 50th most innovative SME in the Netherlands. That's pretty awesome. CIO Magazine also called me the most innovative IT leader of the Netherlands. And also more recently, the European Commission actually called me one of the 9 most innovative women in the European Union, which is pretty cool. So so basically, the reason why we've been winning all of these awards, quite simply, is because of our workflow. It's because of the openness. It's because of the transparency. Certainly also our nonprofit business model doesn't hurt. If you want to know more about that, I'm not going to talk about that today, but I can recommend that you have a look at my TED Talk. I have a talk from TEDx Berlin. If you just Google my name, Ryback, TED, or TEDx Berlin, you'll find it. So I guess that's about it. I hope that you have found this this presentation to be thought-provoking. I hope that it leads you to think about how you could use a chat ops workflow in your own kind of business. And I would be very happy to take any questions.
So thank you, Dr. Melanie, for the nice talk. We have a couple of questions. So the first question is that can you share your experience on when companies, they ask for pen testing and then they ask, okay, where you are spending so much time as a company. So chat ops can help it, but in general, what do you share? How can you share your experience and how many people actually ask you to justify the time you spend on that pen testing?
I don't think it's so much that customers ask us to justify the time that we're spending on pen testing. It's more just that I think they appreciate the openness and the transparency. So it's not necessarily that they demand it, but it's just that they like it. So, because if you come in and get pen tested, it's not really fun to have a pen testing company disappear for a couple of weeks and then they come back with a report, and in that couple of weeks you had absolutely zero impression of what was actually going on. Another thing also is if we find problems, if the customers can actually observe what we're doing, they can actually see the problems as we find them, which basically means that rather than having to wait until the very end when they receive the report, they can actually already start thinking about fixes as soon as we discover the problem. In fact, as soon as we even look at that particular lead. So that's really popular. Another thing also that we do, and we also put into our reports, by the way, are non-findings. So basically things that we tried that didn't pan out. So in other words, what kind of hack attempts did we try that didn't work? It's actually also really educational for the customers to know what we did that didn't work. Because quite simply, all they have to do is make one small change on their system, and maybe next time it would work. So, this is sort of part of why they like this openness and this transparency. It really gives them an optimal look into what we're doing. And this is, I think, part of why they want to know what we're spending our time on. It's not just a matter of holding us accountable, but it's just quite simply because the more knowledge that they have, the more benefit that they're able to get from it. And, in the end, this is why we get a really high rate of return customers. Again, it's not because necessarily because we're pedantically explaining, what we're spending our time on, but it's rather just because we're treating them with respect and treating them like colleagues that are on the same level as us. And, people appreciate being treated that way. And that's why it's so popular.
Right. So another question that you mentioned that you guys are involved in this contact tracing app.
Yes.
Right. So can you elaborate it more?
Yes, of course. So we have been doing all kinds of COVID-19 contact tracing work for both the Dutch government as well as for the European Commission. It's been very interesting. Some of our pen test reports actually have been published. So if you look on the website of the Dutch Ministry of Health, basically our pen test report on the corona melder has been published. It's actually quite interesting because we found some privacy issues. That particular pen test report, it actually got in the Dutch news. It was actually on the very front page of two different national media outlets. And also, even our pen test report got discussed in our first chamber of parliament. We call it the Eerste Kamer in the Netherlands, but basically our Senate. And our pen testing company, actually Radically Open Security, was mentioned 22 times in the course of that parliamentary debate. So that was actually quite interesting. And if you guys want to see, what was in that pen test report, it's been openly published. So feel free to have a look at that. Also, with regards to the COVID-19 contact tracing apps, I also gave a talk that was about roughly 25 minutes long at DevOps Days, Amsterdam. And I think it was called COVID-19 Apps Public Health or Hype. So if you actually also do another Google search on my name, so Melanie Ryback, DevOps Days COVID-19, you'll find this video, and it's actually a really long explanation of really the pros and the cons of COVID-19 contact tracing apps. So what is it good for? What kinds of security and privacy problems does it encounter? Again, I don't want to explain that here because this is a whole separate talk. But what I can do is I can recommend that you actually have a look at this video because I think a lot of people have found it really useful. I guess the too long didn't read summary of my opinion about this is that I'm not entirely convinced of the utility of these apps. And there's still a number of privacy problems that they have to overcome. So a little bit skeptical, but not necessarily surprising. You can also have a look. There's a lot of other great resources also that are out there, and of course, if you read a number of other opinions from other security experts, whether it's Ross Anderson or Bruce Schneier, there's a number of other security experts that are quite critical of this technology. It's not to say that we can't do anything good with it, but it just means we need. I think trade-offs that we're making about our wanting to do something for public health versus the security and privacy risks that we're willing to accept.
So the last question is regarding the open security concept. So how do the companies who have proprietary solutions, so how do they see this concept of this radically open security?
Yeah, so basically, we sign NDAs with our customers. So, I mean, their confidential data and private data stays confidential and private. I mean, it's not like we are publishing their pen test results. We don't do that. So, we basically just, what we're open and transparent in our workflow with them so they can actually see what we're doing. But the actual pen test results, it's for them. Some of our customers choose to publish it, like the Dutch Ministry of Health, for example, published our pen test report. Also, for example, the Mozilla with the Moz project, they tend to publish our tends to publish our reports. But this is always with, with the buy-in, with the opt-in from the customers. So we would absolutely never give away a customer's confidential data or publish their pen test reports. That's not what radically open means. Radically open is in our workflow, and radically open is also in our tooling and the fact that we open source as much as our intellectual property as possible. So I hope that answers our question. And this is also the reason why all these companies that are very, very much commercial and proprietary, whether it's Google, but banks, insurance companies, hosting providers, telcos, but also, software development companies, SMEs, startups, nonprofits. I mean, we really have a really wide variety of customers. But the reason why, especially the commercial companies, we work with 3 different energy companies in the Netherlands. The reason why they find it acceptable to work with us is because, again, their confidential stuff stays confidential. So, yeah. So radically open really only is with regards to process and our own intellectual property.
So thank you, Dr. Reback, for the nice talk. I'm sure you have inspired lots of students here to work on network security and cybersecurity. So thank you. As an appreciation, we will present you with a virtual sheet now.
Okay.
I hope you can see it now.
Yes, I can see it. Thank you very much.
Thank you. So our next speaker is Professor Oliver Olfen. Professor Oliver is a professor and the head of the chair of computer networks at Brandenburg University, BTU in Germany. In his research, he is using a data-driven approach, including user studies, empirical network measurements, and machine learning to understand and improve network performance and security. He has done a lot of work in performance measurements, and he's a young performance measurement guru. So today he will be talking on internet user behavior during COVID-19. So Oliver, you can start. Oliver, can you unmute your mic?
Okay, now it should work.
Yeah, it's working now. Please go ahead.
Okay, now it's working. All right. So thanks for the very kind introduction, Amir. And sorry for only being virtually here today. So when Amir and me first talked about giving a talk here, it was before Corona actually happened. So I was actually supposed to be with you guys now in Pakistan and to give this talk live in Lahore and not via a virtual conference. But still, the good thing is that with virtual conferences, many more people have a chance to actually attend. And so the talk today is about how does the internet user behavior change due to COVID-19? And like the first topic that we looked into this is what's the impact of what we're doing right now? So how do we perceive virtual conferences? What's the user experience of attending a virtual conference instead of being in person? So the research question that we tried to tackle here was, do we really enjoy what we're currently doing? And so what we did was we designed a questionnaire-based approach. So it consists of 2 questionnaires. One questionnaire is a pre-conference questionnaire, and this one assesses the expectations and goals that you have. So if you're attending this conference, what goals do you want to achieve by actually attending it? The second one is a post-conference questionnaire that we then ask the participants afterwards to assess, did the goals and expectations that they have, were they kind of met? And out of this, we derived the user experience. So we published all of the questionnaires as open source. You see a picture of that, a part of the post questionnaire as a PDF on the right-hand side. All of this is implemented in software, so we have an internet and HTML-based version of this that you can download from our GitHub repository. We share all of this for you to actually use. So and then the question was, okay, now we actually want to apply this. We want to make use of this. So we selected 2 workshops and 2 conferences. One of the conferences was the Passive Active Measurement Conference, and we actually run the questionnaire on the participants that actually participated in these conferences. And so we published our results. So this is what you see here on the bottom is a paper that we published about the PAM conference. And some of the lessons learned that we obtained was what's the high-level message of, did people really enjoy virtual conferences? What's the good and what's the bad of virtual conferences? And what you see here is one of the many results that we obtained. And I find this like really insightful because it tells you kind of what you would already expect, I guess, meaning that were people actually more focused on the technical content? So does the primary job of a conference, which is the dissemination of technical content, does this primary job work? And does it work better as in-person conferences? So the reference point here was always in the questionnaire an in-person conference. So we only selected people that have actually attended an in-person conference before. And so the kind of surprising result to us was that people were actually more focused on technical content. So the primary job of a conference, which is the dissemination of research results, knowledge, that kind of seemed to work better in a virtual environment than in an in-person setting. Maybe because there are less distractions. So you cannot leave the lecture room. There is no people outside at the coffee machine to chit-chat with. So maybe that's the contributing factor here, but this is something that from the data we purely cannot tell. The other aspect is that what happens to actual social interactions. So over the year, people have quite made an effort to improve on this, but the results that we got here are the kind of expected ones. So technical content, dissemination of technical content, that works really well in a virtual setting. Social interactions and meeting new people that you haven't met before, kind of not so good. So those are like the pros and cons that we experienced here, and we see that social interaction is kind of the problem. So if we still want to go on with this, then we probably should do something about fixing the social interaction problem, if this is at all fixable, which I don't know. And so one step towards this direction is that we have a Dagstuhl seminar. So Dagstuhl seminars are invite-only seminars of international recognized researchers to the Castle of Dagstuhl in Germany. So this is typically very, very international and very interactive and hands-on. So we have a Dagstuhl seminar. The original title was Towards Climate-Friendly Internet Research. So originally we wanted to go into all this direction of how do we actually design virtual conferences and so on. We proposed the seminar before COVID actually hit us. Now COVID is here. We don't need to design virtual conferences anymore. We are currently doing this, so this is happening. So we changed the scope of the Dagstuhl seminar a bit towards how can we make hybrid conferences actually work? How can we improve the social interaction in these kind of settings? So this is what we hopefully, let's see if COVID lets us, will discuss in January in a Dagstuhl seminar. It will be hybrid, so we have remote attendance. We have probably some people sticking around in the castle, and we try to derive schemes of how to actually make successful hybrid conferences. So this is something that we're currently doing, and when I say we, you might wonder, okay, who is that? Who am I? Amir said a little bit, I'm Oliver. I'm currently a full professor at Brandenburg University. So now the next question that probably pops up in your head is, where on earth is Brandenburg University and what the heck is that? So Brandenburg University is the technical university in the state of Brandenburg. So if you wonder where this is, then you see a map on the right-hand side of the screen. So Germany is divided in a couple of federal states. One of the federal states that is surrounding Berlin is the state of Brandenburg, and BTU is the technical university in this state. And so what you see here is our nice computer science building. So this is where my office is and where my group is currently located. And now the next question is, okay, what are you doing in this kind of office? What's the kind of research that you're working on to kind of know me a little bit better? So as Amir said, I'm a performance guy, I'm a measurement guy, so I really like measuring stuff in terms of measuring network performance, measuring network security. We run an active internet observatory, so that's the NetRay Internet Observatory. And I typically perceive gathering data or this data science approach as kind of the first step that we actually have to start with. Because if we want to optimize the system and make it better, we actually have to understand how the system is currently operating. So what are the problems? What are the current drawbacks, the performance bottlenecks, and all of this? So we have to first understand this, and we need large-scale measurements to actually gain a empirical perspective on what a system like the internet is currently doing and where the problems are. Once we have obtained this understanding, we can then go ahead and improve the architecture, make it work better, make it faster, and so on. But as a last step, we don't have to forget the users, because in the end, the internet, all of the technology that we're doing, it's mostly for us. So the end users that are actually consuming this is us. It's humans. So we have to look into human perception. Do we actually like how the system is working? Do we enjoy it? Do we have to make it faster? Do we actually perceive performance improvements? Because if you made something like 1 millisecond faster, but very few people actually perceive it, maybe it's not worth the effort. So I argue here that the last step that we have to go is into more a psychological dimension and do user studies. And like an example of that, have you seen in the beginning, like the work on virtual conferences? So with that, I want to dive into the next part of it, like how does COVID actually change the internet? And what I'm going to tell you now is more or less a success story. So COVID-19, the pandemic and the internet, they kind of worked out really well. So the internet was a big success story here, and it enabled us to do or to keep up doing most of our social life as to the largest extent possible. So for example, to have this conference right now, not in person, but at least in a virtual format. So we can meet, we can have these talks, we can exchange ideas. And all of this is only possible because of the internet. So what we want to look into is like, what does the internet enable? And how did the internet actually cope with this pandemic? So how was it impacted? And I will start here with the first example that we looked into. So this was mentioned in the discussion to the last talk, about these contact tracing apps. So a lot of governments here in Europe have put effort into designing contact tracing apps that are utilizing, most of them are utilizing the APIs that Apple and Google have implemented, so the exposure notification APIs. And the idea here of these contact tracing apps is to kind of understand the infection chains. So to kind of cope with the pandemic by understanding the infection chains and do all of this electronically, because what the health ministries are doing here is that they do manually contact tracing. So they actually have to call people and understand, like, okay, and if you are infected with COVID-19, what are the set of people that you have met in the last 14 days, so that we can also inform them that they also are possibly infected. So the infection kind of spread. And they're super overloaded with this. So the idea here was to use electronic aids, so internet-based gadgets, to actually help and improve this contact tracing. So what you see here is the Corona Warn app. So that's the official app, contact tracing app that was designed by the, or funded by the German government. So this is the application, the contact tracing application that we should be using here in Germany. And as I said in the beginning, many of the different other governments here, they have designed their own apps, but technically they are all based on the same technological foundation implemented by Google and Apple. So what we looked into, like one of the studies that we did earlier of the year, was once the German government launched the Corona Warn app, so our official contact tracing application, we wanted to understand, by taking a measurement-based approach, like, how well is this doing? How are people adopting it? So we were not, like, as it was discussed in the previous talk, we were not actually interested in okay, what's the how effective is this? What are the privacy implications? We were just interested in, okay, do people download this? Do they actually use it? So what are the traffic patterns in terms of usage, and what can we derive from this in terms of the adoption of that? Because if this contact tracing approach, this electronic contact tracing approach, should be successful, they need a large adoption among the population. And this is what we wanted to look into. And so this is a study that we did with a couple of people. So one was Helge, that you see on the left-hand side. He's in my group. And the other one was Ingmar, that you see on the right-hand side. So he works for a data network analytics company that is called Banox. And so this is the three of us doing this kind of study and looking into the adoption pattern of this application. So the Corona Warn app was released, officially released by the German government on the 16th of June. And so far what we have seen is that all of these electronic contact tracing applications are kind of new terrain to us. So we didn't have this kind of technological aids before. So it's new, it's therefore not very well understood. So this is like a large field test that we're doing right now. And the main goal, as I said, of these applications is to suppress further spread of the virus. However, the success depends on isolation. So this is absolutely not dependent on a smartphone and electronic aids. So this is something that we as humans need to do, and the adoption of the app. Because if nobody is using the application, then it's not very helpful, and it cannot actually help to suppress the infection chains. So the goal of this study was that we wanted to study and analyze the official launch of the Corona Warn app for Germany. So how does it actually get adopted by its users? So we saw that here the application was launched in mid of June, and by the end of June, it already had 16.6 million downloads. So that's roughly 20% of the population. Of course, not all of them have smartphones. Some of them are kids. So if you take them out, then probably the adoption figure is a little bit higher. But downloads, of course, they don't tell us the whole story. So downloads, it's not everything, because you can download the app from the App Store and never use it. So we actually decided to look into the traffic and capture the traffic directly at the data center that is hosting the application to have like a complete picture of what is going on right now. So, and with that, we're measuring the user behavior and the interest in the application. So I give you like a brief overview of how the application works so that you have a way to understand what this Corona Warn app or these contact tracing applications are roughly doing. Is that you have a bunch of smartphones in your direct proximity, so in the direct proximity of your smartphone, and the Corona Warn app is sending Bluetooth beacons, or more or less the frameworks by Google and Apple are sending Bluetooth beacons that are then received by the neighboring smartphones. So then by receiving that, you know that you're actually in close proximity. So all of this data is anonymized, so it depends on like a cryptographic scheme so that the keys are changed every couple of minutes. So you can't actually trace users over a longer period of time. So there was a lot of effort being put into trying to make this as privacy sensitive or privacy conservative as possible. So that's what the Corona Warn app is doing. It's controlling the API of Google and Apple to perform this Bluetooth scanning and receiving these beacons from other nearby smartphones. But that, of course, doesn't help you because you don't know, like these beacons are not telling you, okay, well, I'm an infected person. So you still need to know if you were in close proximity to an infected person. And this happens actually by downloading anonymous infection keys from a central data center. And so these infection keys are cryptographic hashes by people that have been diagnosed positive with COVID. So you can match all of these keys that you receive from the central server against the data that you have stored locally from these Bluetooth beacons, and then do a matching. If a key is matching, you know that you were in at least proximity of an infected user. So if you're infected yourself, you can opt in to report your infection and upload the diagnosis keys. And those are the keys that you have used over the past 14 days also to the data center so that they can be downloaded by other users and then get used here. So of course, all of this needs help from the central authorities because so to prevent fraud here. So if you were performed lab testing, the laboratories themselves have to also upload these results to the central server so that this is kind of verified. And then, of course, there's the website that provides information on how to download the application, how it works, and all of this. So this is kind of the infrastructure as it looks like. And our vantage points from where we have obtained data are directly at the data center that is hosting all of this. So what we have included in our data is website retrievals, which we cannot tell apart because of cryptography. So encrypted data transfers from the actual API requests of the Corona Warn app, but we treat all of this as interest because whenever a user is visiting the website or using the application, there's clearly interest in the application in one sort or another. So that's kind of the traffic that we looked into. And what I'm showing you here is like a result of the very first days of the Corona Warn app in Germany. So you see here on June 16, this is when the application was released. So that's the official start of the application. And then you see that the traffic in terms of the number of flows and the number of bytes is immediately ramping up on the very first day after the launch. So you might wonder, okay, well, but there's also traffic before. So on the left-hand side on June 15, but remember that the data also contains the website retrievals. And of course, the website was active before the Warn app. But you see here that once on June 16, the application became available in the App Store, the traffic was immediately ramping up. So another incident that we have here is a partial lockdown or a lockdown of the district of Gütersloh in Germany. And we were also interested in, okay, how does a lockdown or a partial lockdown of a district in Germany impacts the usage of this application? So does it actually needs to increase usage here? But of course, we see here that the traffic and the interest that is actually behind all of this traffic is increasing but by whom? So who are these users? And of course, like the data that we have is anonymous, but we can use the routers, the router locations of the DSL users. So not the home router location, but the broadband access routers to actually tell where this traffic is actually originating from, or if we don't have this information, we use IP geolocation. And what you see here is a map of German districts, and it's a heat map. So the lighter the color, so the more it goes into the yellow, then the higher the usage is in terms of traffic. And what we see here is we're not so much interested in how much traffic is generated by which district, because this is also like largely dependent on the population density and these sorts of things. But more likely, we were more interested in, is this map completely filled? So is there interest in this application throughout Germany? And you kind of see that it is almost completely filled. So there are a few gaps in here, but most of the map is actually filled. And this is a good news. So what we observed in already like the first 10 days after the launch of the official COVID-19 contact tracing app, there was interest in the application on a countrywide basis. So this is something that we considered like really good news, and that we looked into. So yeah, I said we were really interested in the user behavior here. So do local outbreaks increase the local usage? Well, in the first days of the application, from what we've seen in the data, no. So that doesn't seem to happen, in fact. Do outbreaks increase the countrywide usage? So if we just don't look into the affected district, but we look into a countrywide usage, yeah, possibly. We might speculate about some artifacts here in the data. Does coverage by the news and media increase the usage of the application? Possibly as well. But of course, like this is ongoing research. So what I showed you here is like the beginning of the adoption, but we're still, of course, like continue to look into this. So these are the first days, but this is ongoing research. So we are looking deeper into this kind of data, and we're interested in, can we actually turn these measurements into insights for actually increasing the application for the general good? So that's something that we're currently looking to. So far about contact tracing with the help of the internet. Then the last chapter that I actually want to talk about is what actually happens to the internet traffic. So far we have talked about applications, we have talked about virtual conferencing, we have talked about contact tracing applications. So those are all applications that are using the internet. But what actually happens to the internet itself? And by the internet itself, I mean internet traffic. Once the entire world changes its behavior at once. So once people go into lockdowns and governments impose lockdowns. So how does this impact actual internet traffic? So that was the next aspect that we were interested in. And so this is a paper that we just published and that was presented in October. So at the ACM Internet Measurement Conference on the lockdown effect. So the effect of the COVID-19 pandemic on internet traffic. Why is this relevant? It's relevant because our activity is increasingly moving online. So the web is now the narrow waist of all of our activities. We use it for retail, entertainment. All of this is now online. There's a convergence of the physical and the virtual world and these kind of social networks that we all use. So the internet has become like really important for all of us. And in the beginning of the year, we saw that there's changes in our human behavior. So half of the humanity is now under lockdown because of government-imposed confinement measures. There were now claims about, okay, we have a new reality. We have to work from home office. How does this impact the workplace? People are studying online. So education at both at the university, but also in the high schools is also shifting online. So how does all of this impact the internet? All of our social life is also moving online. So we now use our smartphones to do actual video calls with our loved ones, with our family, and so on. So the internet has become like a really crucial part here in all of these efforts. Now the question is, okay, can the internet actually withstand this change in user behavior once we actually move all of this online? So can the internet survive COVID-19 imposed traffic shifts? So there were lots of concerns in the beginning of the pandemic. So the internet changed the way we use the internet. It puts a lot of strain on the internet. Can it actually cope with that? So that was a number of concerns that were raised in the beginning of the pandemic. And we actually decided to actually look into this. So what was actually happening? How was the pandemic really impacting the internet? Did we have a problem here or not? So we wanted to understand the impact of the COVID-19 pandemic from a set of different networks, so core networks and both edge networks. And really look into like, what is the effect of these user level changes that we have in here. So those are the study goals. In order to understand all of this, we needed a big team. So we needed lots of data to kind of understand, broadly understand the impact of the COVID-19 pandemic. So we had lots of people involved here in like a really fantastic team from a large set of different institutions. So the Max Planck Institute for Informatics, the Banox data analytics company, the KICS Internet Exchange Point, the University Carlos de Terros in Madrid, IMDEA Networks, my own university, TU Berlin. So it was a big and fantastic group of researchers that was coming together here to kind of understand these big questions. And so we needed vantage point for this. In order to understand this, we need data, and the data comes from vantage points of where we actually capture the data. So we had multiples. We had data from 3 internet exchange points. So those are central places where networks interconnect. So this is really in the core of the internet where traffic is being exchanged by bigger networks. So here we had data from 3 internet exchange points. One was located in Central Europe, one was in Southern Europe, one was at the US East Coast. They have different properties. So the Central European one is a very big internet exchange point. So there are more than 900 networks actively peering. They exchange more than now it's more than 10 terabit of peak traffic. So this is fairly substantial. The other ones are different in scope. And because the data is kind of critical here and privacy matters, all of the data was analyzed strictly on-premise in an anonymized way, and all of the results were kind of aggregated to kind of respect the user's privacy here. Another data point that we had was from a big internet exchange internet service provider that was located in Central Europe. So this is the place where residential customers connect that are working from home. So if we see home office imposed traffic shifts, we will probably see them in this vantage point here. So that's a big ISP, and actually it has about 15 million subscriber lines and a tier 1 transit network. It doesn't host any CDN caches, and as with the internet exchange point, the data was analyzed strictly on-premise, and only aggregated results were actually used here. Kind of the last network that we looked into was a big educational network in the Madrid region. So this is where a number of universities and research institutions actually connect to gain internet access and to exchange data among themselves. So this is the kind of data that we obtained here. Here again, for the educational network, it was provided by us from the provider, so Ready Madrid, in an anonymized way. Of course, I haven't covered Pakistan here, so this is something that, of course, I would love to look into. So if you happen to actually have data, traffic data, about Pakistan's ISPs in Pakistan, I would be more than happy to actually talk to you. So now let's look into the actual results of what we find here. So what I'm showing you here is the evolution of traffic at all of these vantage points, now starting with the ISP over a period of 1.5 years. So on the left side of the plot, it starts at calendar week 0, which is the beginning of the year 2019. So we start in the last year, and then this moves on till the end of June this year. And what you see here, the blue curve here, this is the curve for the big internet service provider, and the traffic volume here is normalized to the minimum value here, so to kind of make it comparable between all of these different vantage points. So now we can look into 3 different aspects here. So the first aspect, if we just focus on the year of 2019, which is the year on the left-hand side that you see here, we see that there is a traffic growth, so an increase in traffic by about 20%. So if you go from here, so 0.8 up to 1. So that's about a 20% increase in traffic, but over the course of the entire year. This is now important. If we now look at the right-hand side, so the year 2020, then we see here the beginning of the year. This is when the COVID outbreak actually happened in Europe. And now the gray shaded area here, this is when lockdown measures were actually imposed. And now what we see here is what where the title of our paper comes from, the lockdown effect. And here we see that the traffic volume is actually increasing by more than 20% in just a few days. So this is fair. This is extremely significant here, because the increase that the provider has to actually manage and cope with over the period of an entire year now happened in a few days only because of these lockdowns measures. So this is a fairly substantial effect on network operation. Now, this is just the internet service provider. You might ask, okay, but we have more vantage points in the data. So how does it look for the other networks that we have studied? So here's the data from the internet exchange point. You kind of see the very same pattern. If we now look into a cellular network operator, you see here, so that's the orange line, that the cellular traffic actually declines. So it decreases during these lockdown periods, which is kind of expected because the mobility of the users is actually limited. And then, of course, this takes up again here in April as the relaxations of these lockdown measures actually kicked in. So let's look into the actual traffic volumes that were exchanged before and after the lockdown. So this is our base period in February. This was before the lockdown measures actually looks like. And you kind of see here the classical seasonal pattern. So this is the point at 4 a.m. or 5 p.m. in the night when the internet sleeps. And this is the peak hour when most of the traffic is actually exchanged in the internet in the evening hours. So this is kind of the internet traffic as we used to know it. Now, what actually happens once the first lockdown week happens? So once these lockdown measures kicked in, we see here that the peak traffic actually increases substantially. So we see here a 30% increase in the peak. So on this evening here on Saturday, but also there's more and more traffic being exchanged here over the course of the day. So we just make more use of the internet. Once you look in further ahead of time, so now into April and June, you see that this is going down a little bit, but some of the trends, they actually stay. So it's going down a little bit because the lockdown measures are reduced and some of the workers actually or possibly return back to their offices. So the next thing that we were looking into was how does it actually change? So how does the pandemic change the daily patterns? And what we see here is that the internet, because of the lockdowns or during the lockdowns, the internet actually starts to look like every day in the internet starts to look like a weekend. So what does this mean? If we look here at the Wednesday in February, this was before the pandemic really hits us here and before the lockdown measures were imposed. So you see a normal day in the internet. So this is where we sleep. This is where we are at work. So there's increasing, but not so much activity. These are the evening hours where we actually go home or return home from work and start to consume video services, start chatting online. So we start to really make use of the internet. So that's a classical day in the internet. If we now look at the Saturday, then of course this is shifting a little bit. So this peak here stays, but because we're not in the office, we make more use of the internet over the entire day here. So the traffic levels increase starting in the morning. Now let's look into a Wednesday. So that's clearly a working day, but during the lockdown. So this is March 25th. And you see here that the internet is actually the usage. It looks like a Saturday. So we don't have this, this slight increase here towards the peak hours in the evening, but we actually have a substantial usage of the internet over the course of the entire day. Now we try to classify this at both of the data points, so the ISP and the IXPs, and what we arrive here is that most of the work days during the lockdowns are actually classified as weekends because of this pattern. So we make more use of the internet during the week or during the normal working hours because we are sent to home because of home office lockdown measures and all of this. So this has a substantial impact on how we utilize the internet. And we now wanted to understand that, okay, what are the applications that are behind all of this traffic changes? So we looked into a transport port and autonomous system-based classification. And what we see here is that the 8 traffic classes that we actually looked into, so video conferencing, which is what we're currently doing, collaborative working, email, video on demand, gaming, social media, educational traffic. So this is not educational applications, but traffic towards educational networks, so universities and so on, CDNs, and this over the course of the day. So the day starts here and the evening hours are more to the right-hand side of such a cell here. So what you see here, this is a base week in February. This was before the COVID-19 lockdowns. So we see mostly email here during the working hours. So on the left-hand side of these cells here, on the work days, we see video and gaming mostly in the evening hours. So towards the right-hand side of these cells here. And there's hardly any web conferencing. Now let's look at the actual interesting comparison. So let's look how the COVID-19 lockdown actually changed all of this. So here's the changes in the application classes when we compare a period of March, when the lockdown was actually in place, to our base period in February. And this we look into at the Central European ISP. So what we see here, there's a large increase in web conferencing, collaborative working, and a partial decrease in video and demand of gaming. So the gaming is a bit of an artifact here because in the base period, there was an unexpectedly high volume of gaming traffic at our vantage point. So this explains why this is actually measured here as a decrease. The video on demand part here is actually an interesting one because many of the big providers like Netflix announced that they will reduce their streaming rates because of COVID. And we might actually see effects of that here, but we are not sure. If we continue to look this further, so this was March. If we look now into the comparison of April, we see that the growth in email is actually less pronounced. There is a decrease in social media usage. And if we look into June, then the video conferencing traffic is still growing, but actually it's getting more focused on working hours. So we're getting back into the offices probably. If we compare this at the Central European IXP, then we actually arrive at a fairly similar pattern. So there is a large increase in web conferencing, video on demand, and gaming, and a partial decrease in actual CDN and educational traffic. So basically what we can say here is that everything that is related to staying at home sees an increase. And one particular case study that I want to pick out here is the one of gaming traffic. So this is gaming traffic studied at the Southern European ISP. So we see here the normalized number of unique IPs, so internet protocol addresses. And we see here a substantial increase in the usage, so in the number of users that are actually using gaming applications when these local lockdown measures are actually in place. So the number of gaming users and the traffic is actually increasing during the lockdown measures. So we see a very good correlation here. With VPN usage, so that's kind of virtual private networks that we need to, in order to do remote working, to connect to our company networks, we see a very similar increase, so about a 200% increase in VPN traffic in March during the working hours. And this is all people working from home using VPNs to actually connect into the company networks. So we see then a slight decrease in April. How does this change the educational network traffic? So here we see actually the opposite effect. So what happens to a place like a campus where all the persons are actually sent to home? Of course, they can generate less traffic. So less traffic is going from the campus network towards the internet. And more of the traffic is actually consumed from the internet or from servers on this university. So what this changes is it changes the traffic ratio, so the ratio of ingress, so traffic leaving the campus network, and the egress traffic here. And you see, so this is the base period before the lockdowns. Once we go into lockdowns, this traffic actually becomes fairly symmetric. So the traffic patterns substantially change here. And this has a large impact into network engineering and dimensioning. So to conclude this, people change, traffic changes, and we can see that actually changing people's lives leads to new traffic patterns that emerges. So we see that the difference between workdays and weekends vanishes. So during the lockdown, everything starts to look like a weekend from an internet traffic perspective. So there is a substantial traffic shift in all the applications that are related to staying at home. So for remote working, education, VPN, video conferences, all of these applications see an increase in traffic. For the educational network, we see that the absence of users can actually lead to a decrease in traffic. So there's a big impact here. And of course, like in the beginning of the pandemic, people were kind of worried if the internet can actually cope with this increase. So if we start to make use of the internet in a higher way as we did it before, can the internet actually cope with that? And what we observed throughout the vantage points was that the traffic increases to about 15 to 30% within a few days. So this is fairly substantial because we have to remember that networks typically provision for about a 30% increase per year. So we pretty much quickly made use out of what was dimensioned for the rest of the year. Other than that, the impact on the peak traffic was actually limited because the valleys got filled. So that was this weekend effect. So the traffic shifted to other non-peak hours of the internet. And I think that was a big part of why COVID-19 was very friendly to the internet. Of course, many networks needed higher capacity. So we also observed increases of port capacity increases. So at the Central European Internet Exchange Point, there was an additional capacity of about 1.5 terabits that were added because of the needs of the COVID pandemic. And here the networks kind of reacted very, very quickly to actually provisioning new capacity. And this is a result of very good engineering, having robots that cannot be sent into a lockdown that actually provision some of the links here. So what we conclude here is that networks can actually accommodate a sudden change in demand if they're planned with spare capacity and they're able to quickly react and add this additional capacity that is needed here. If you're interested in that, you can find the paper here by actually scanning this QR code or by Googling for the lockdown effect paper online. With that, I'm at the end of my talk. I thank you for attendance, and I'm happy to take questions now.
Thank you, Professor Oliver, for a very nice talk and showing us some familiar faces that I've already worked with. So we have a couple of questions. The first question is regarding the COVID-19 app. So how the app was designed to preserve privacy of the people?
So it's privacy preserving in the sense that so it does scan for local beacons that it receives, so from other cell phones that are around you. This data is not shared, so it does not leave your smartphone. So it's stored locally in an encrypted database, and it does not leave the smartphone. So in terms of like the contacts that you encounters are only stored at your smartphone, and nobody else gets to know about this. This is in kind of like stark contrast to some designs of the other apps that were changed that use a central server. So in other contact tracing apps, the Bluetooth encounters that you made, they're all uploaded to a central server and then processed there. And this kind of centralized design, it raised a lot of red flags for in terms of users' privacy, because you could actually engineer the social contact network of these persons out of this centrally collected data. And with this exposure notification approach that was implemented by Google and Apple, they actually tried to work on this criticism by actually storing this contact tracing data only locally at your smartphone. So it's never shared with a central server, and it doesn't leave your phone. The only thing that is shared is that if you are tested positively, you can voluntarily, so you're not enforced to do that, but you can opt in to upload your test result and say that I have been diagnosed positively. Here is the set of anonymized encryption keys that I have used in my Bluetooth beacons over the past 14 days. And you can voluntarily decide to upload these to the central server. If you do this, then other users can download it and then do the matching locally against the Bluetooth beacons that they have encountered. If this local matching shows you that you have actually been in proximity with a person that was later tested positively with COVID, then you can actually take action on this and then, for example, go in quarantine. So, but the important piece in terms of preserving the user's privacy is that all the critical data is only stored locally on your phone and never leaves your phone.
So the second question is regarding service providers network expansion. So as we all know that service providers takes a lot of time to expand their network to provide more traffic. But in this case, you observe like within days, 20% traffic actually was increased. So how did they manage that capacity, that sudden surge demand?
That's a complicated one to answer. So I guess the first part of the answer is over provisioning. So if you have an over provisioned network, so for example, if you envision that your traffic level is increasing by 30% over the course of the coming year, then you're over provisioned by a certain share. And then, of course, this kind of rather sudden increase in traffic was eating up the buffer space that you have allocated in your over provisioning. So that's over provisioning is kind of part of the answer. The other thing is that we observed that many of the networks that we looked into, they reacted rather quickly. So, so for example, KICS employs robots, and I think other internet exchange points have that as well. You can't send robots into a lockdown. They cannot, you know, they don't need to be sent to home, so they can work, and like many of the networks were able to react very, very quickly and add new capacity within a few days only. So many networks were like have like pretty good engineering teams in order to support this and react very quickly. Of course, we have also seen like spot effects of networks that were not able to actually do this. So of course there are examples of networks where you know, the links get filled and they simply run out of capacity, or the provisioning simply takes too long. So this is not like a generic answer. So this is what we have observed for most of the networks, that they sometimes do over provisioning, or they're like at least very quick in provisioning new capacity. But of course, there are these other networks that actually had trouble. And this can span all the way. So, for example, if you, you know, envision that, yeah, if we need more network equipment, we can get it in up to 6 weeks from China. And then, you know, flights are decreased and the borders are closed, then you can run into troubles here. If you envision that, okay, if we cannot get our network equipment or new network equipment from China, but from our friendly neighboring ISPs, and you cannot travel because of travel restrictions, you also run into problems. So there are also reports by operators and all sorts of these kind of problems that they run into that actually challenged provisioning new capacity for them. So yeah, you see both of this happening.
So the last question is regarding the first part of your talk, the user satisfaction in the virtual conferences. So as we are right in the middle of the COVID-19 second wave, we don't know when this is going to end. So you mentioned that we might use hybrid approach. So can you elaborate on that? What do you mean by the hybrid approach?
So this is kind of beyond COVID. Hybrid means that you have a few of the participants attending remotely and a few participants attending in person. So that is what we refer to like a hybrid approach. And then the question is, how do you actually combine this? Because the virtual participants are kind of challenged by additional network latency that impacts the turn taking in discussions, and all of this. So the question is like, how can you make a hybrid scheme a successfully one where the remote attendants are challenged in terms of they're not physically present, they suffer from additional network latency and all of this. So we need to design a way to actually make this fun and enjoyable. And the reasoning behind is that some of the people think, and I as well, is that the hybrid mode is probably something that will actually happen after COVID-19 is done. Because there is a certain benefit if you can attend conferences remotely without needing to travel. So without actually also having to spend money for affording the travel. So what we have seen over the course of the past months with almost all of the virtual conferences that were happening was that they received record numbers in terms of registrations. So more people, more attendees than usual for an in-person event actually attended the conference. So in terms like these venues were doing much better in terms of like disseminating their content to more people. And so this was a success scheme here. And the reasoning behind the hybrid mode is that can we keep part of this success? So can we enable more people to actually attend these conferences without having to travel? While keeping also the benefits of in-person conferences. And the thinking here is like, how can we then go into a hybrid mode where we accommodate both kind of participants? So online, at home, attending a conference from your sofa, and also going there in person.
Okay, thank you, Dr. Oliver, for your nice talk. So at the end, we will present you with a virtual shield. And someday, inshallah, we will present you here as well in Lahore.
I'm very much looking forward to coming to Lahore for the next time. So thanks for all of this. Thanks for having me. This was fun.
Thank you. So with this, our session is concluded. So we have a few announcements. Tomorrow, we have two more sessions. In the first session, we will have a talk from Mr. Sider. He will be talking on ascent to pervasive intelligence. And Dr. Giorgio will talk on wearable sensor data to predict COVID-19. And Dr. Junaid Qadir will talk on the ethics of artificial intelligence. In the next section, Dr. Ying Lu will provide some information on bridging the gap between lab-grade technologies and practical challenges. And after that, we will have a panel on fighting COVID-19 with innovation and inherent problems. So tomorrow we will start at 9:45 a.m. So I hope to see all of you tomorrow again. So Allah Hafiz from our side. Allah Hafiz.